Okay, good morning, dear colleagues, and welcome back to the 27th International Conference on Information and Software Technologies. And let me introduce our keynote speaker. His associated professor, Dr. Christian Grimme. He is a computer and data scientist and heads the social media analytics working group at the Data Science, Statistics and Optimization Chair at the Institute of Business Informatics at the University of Münster. Good morning, Christian.
Good morning.
So the floor is yours.
Sorry?
So you can start.
We can start. Okay, great. Thank you very much for your introduction. And I try now to share my screen actually. So now I hope you can see my slides.
Yes, perfect. We can see.
Perfect. So then, and if you can also hear me, I will try to give you now in the next, let's say, 40 minutes or so, a small overview on what we are actually doing in our working group and beyond, and also on a very specific topic in the area of disinformation in social media. And I will specifically focus on social bots, but I come to this. So, okay, let's take the next slide. So, actually, this is what it is all about. It's about disinformation, but before we discuss what disinformation or what the technologies behind all this are, we probably first need to define what specific case we are looking at. And here I use the classical information disorder classification by Waddell. And if we speak on information in social media, and also false or true information on social media, we can, and also with a malicious background, background of usage, actually, we can define this information in three types. So the first type is misinformation, which is usually not used to harm anybody, but which is still doing harm just by incident. So you share information, for example, via social media, and this does some harm, but you don't intend it. So this actually misinformation, in contrast to disinformation, which actually is information which is knowingly shared to cause harm, for example, to society, to people, to individuals, and so on. Yeah. And then there is malinformation, and malinformation is a very interesting kind of information. Actually, it's a genuine information, so true information about a person or a group of persons, but it's knowingly or willingly shared to cause harm. So, and to use all or this information can be shared in different ways. For misinformation, it's usually just by incident. So you do it manually by just clicking a share button in a social network, and then this information is somehow shared and in public. And then disinformation is something you usually have a strategy behind it, and you have a will behind it to distribute this information. And in this case, you use some tools. You can use humans to do this, or so in a kind of paid trolls, for example, so guys who just publish this information in social media. But you can also use other tools to do this. You can make up some kind of news, which we usually define as fake news, or you can, for example, rely on automation, which are social bots. And in the malinformation case, you usually get your information from data leaks, so information which should not be public, but you get it somehow by usually criminal acts or by whistleblowers or whatever, and then these information is distributed again via media and social media, but you don't need necessarily automation or things you need in disinformation, because this malinformation is usually so critical that it distributes by itself. So what we deal today about is disinformation, and probably you all know some of the incidents and cases which are discussed in this context. So, for example, it started in the public, the discussion started strongly with the Brexit, or with the election of the US president, former US president, and also here in Europe, and specifically also in Germany with the so-called refugee crisis. The people coming from, for example, Syria, to for asylum in Europe and also in Germany. So these were cases where disinformation was very strong. And what we specifically discussed today is the specific component of social bots. This is something we did some research on, and which is still in very strong discussion also in this area. And I will try to shed a little bit of light in this context, and reflect on the discussion, and show also my opinion on this. So this is what will happen now. Okay, so actually we have a kind of research history of 10 years. And in these 10 years, there was very early research just before 2016, but with 2016 and actually the Brexit and the election of Donald Trump as US president, there appeared, let's say, a milestone paper in this area. And this milestone paper was the rise of social bots. This was a review article on the very early research, and also it actually paved the ground for this community and for this research area. And now, about 5 years later, we have another paper, which is maybe not a milestone because the guys are not so famous, but actually it's directly in the contrary of what the rise of social bots say. So they actually argue against social bots. So let me sum up all this in a small comic, which I try to make up actually. So what the rise of social bot paper more or less said was that there are a lot of social bots, and the following publications of these guys and others actually told us that bots are more or less everywhere in social media, that they even have about up to 15% of the communication in social media and in Twitter and so on. And that social bots may also act very intelligently, and that they infect elections or manipulate infections and change the perception of people. Now, the paper from this year actually says, well, no, there are no social bots. So poof, social bots are away. And basically, behind this social bot topic, we have scientists. The scientists actually invented this story of social bots to get funding. So basically, these scientists are nothing more than conspiracy theorists. So you see what is actually shown in this kind of comic. There are two very strong extremes in our research community. The one who say, well, there are a lot of bots and they can do a lot of things. And the other says, well, there are no bots. So The question is, why now, today, in 2021, there are no, how do they come to the conclusion that there are no bots? So basically, the reason is that the bot detection, so the mechanisms to find bots in social media are rather weak. And I'll just give you two examples for these mechanisms. These are actually very famous mechanisms and mechanisms which influence the field astonishingly. So the first one is the so-called Oxford criterion, which is named by the authors or the location where the authors came from. And it's actually a very simple criterion. It just says the social bot is an account in a social media channel which posts on average more than 50 times a day. You see directly that this is something very arbitrary, probably, and this, also a human can do this. Usually, maybe a human does not do this, but a human can also do this. So it's not a real criterion to just classify social bots. Still, a lot of research and also a lot of initial research which formed this field and also formed the discussion, the public discussion on, for example, the Brexit and also the US election was based on this criterion more or less alone. And also some services which were published during the German federal election and which evaluated the German federal election were based on this. So this is one very weak kind of detection mechanism. Another one is a detection mechanism which is by design a little bit more complicated. It's actually a machine learning based approach that evaluates the degree of automation of accounts. So you can put in an account in a web interface and the mechanism is somehow evaluating this by a model which was learned on initial data, which was manually tagged by others to train this machine learning algorithm. And this is very, very popular mechanism, and it's usually used because you have a web interface and an API. You can use this to do a lot of research by just classifying your accounts and finding out whether they are bots or not. The problem is that this mechanism is not very reliable. So I brought an example here. These are 4 accounts which we evaluated with this just as an example. And actually what you see here, if it is red, it's a bot. If it is blue, it's not a bot. And so red is 5, blue is 0. And you see here in this small box that we have evaluated 4 accounts. Well, of course, Donald Trump is not a bot, although he posts a lot. Or posted a lot. He was still the president when we evaluated this, but probably he was hard-coded as not a bot in there, and he also has a validated profile into it. The Pontifex is not classified as a bot. Well, that is clear, probably. Yeah, he's a holy man, so he cannot be a bot. Actually, but if you look at this account, it's definitely kind of automated because this account actually posts not only in German, but also in 200 other languages. And there is probably not a Pope who sits there and translates all his messages to 200 languages and provides it via Twitter. So the funny thing is, however, here my account is very bot-like, so I'm probably behaving like a bot, but I'm definitely not, I can assure you. And the other thing here is there is this account which the algorithm is not able to classify in any way, which is definitely a bot. It's a bot we designed and which we used for a long time for our experiments. So this is, here the algorithm is not sure. So basically, this is a problem with this algorithm. It is not able to detect reliably whether it's a bot or not. This is a principal problem of this machine learning approach, because the situation in social media is rather dynamic. Accounts are changing, behavior is changing over time, and this model is learned once, just in 2016 or 2017, and there is a new model which was learned again in 2019, but these models actually are fixed, and they are decision rules, and these decision rules cannot adapt to changing behavior and also to change in use of accounts. An account is usually not always used by a bot, but also by a human, and then it is again difficult to classify a single account according to behavior over time. So this is a real problem, and this makes these detection mechanisms very weak. And as a lot of science or scientific results base on these mechanisms, the author from the aforementioned paper actually claimed that there are no bots because the detection is not working correctly. So yeah, so the question is, does it solve everything? So bots are discussed away, there is no detection, so there are no bots, and everything is good. Probably not. So from my perspective, and this is my claim, social bots are real, but they are currently far simpler than what we may assume. And bots are only a single tool in a much more complicated disinformation context. So we have to broaden our view and to look on other effects and other things which also take part in disinformation strategies. And from my point of view, we should not stop looking at social bots because we should not underestimate their future potential. And I will elaborate on this as well a little bit later on. So actually, that was a brief overview of my talk. Let me give you a little bit longer outline now and then go into some details. I will start with a definition of social bots, then give a little technical perspective on what social bots are from my perspective and what it costs to build them and how complicated it is to build them. It's actually one piece to show that social bots may be realizable, may be real. It's not a proof, but it's one indicator. Then I would like to change the perspective, and I would go to the broader topic of campaign detection. And in this campaign detection, actually, social bots can be something like bycatch, which we find there. And I want to show you some very recent results, which are not yet published, on automation in campaigns, specifically the German general election, where we found some automation and where we detected it by these unsupervised mechanisms, which I will show you. And then I will, in the end, speculate a little bit on questions for the future and future challenges, and try to conclude everything. So this will be thing for the next half hour, I hope. Actually, some of these results are based on papers which we have already published in my group, and I will go into some of these papers in some details. So first of all, let's have a look on social bots and on their definition and also on some examples. So first of all, a definition of social bots is given here. It's a definition by my group, and this is something which tries to actually sum up a lot of definitions which are out there. This is definitely not the only and the best definition maybe, but it's from my point of view a definition which sums up the functionality of a social bot and the goal of the social bot. So we see social bots as a superordinate concept which more or less summarizes very different types of semi-automated agents which act in social media, and they are designed for a specific purpose by reach this purpose or to have an effect by means of one or many-sided communication. So the basic thing is communication in this, because social networks are communication platforms for mass communication and for one-to-one communication. Okay, and of course you can now define different types of social bots, and one type of social bot is a very easy and very simple social bot. It's a kind of mechanization of communication, again communication, and it's more or less nothing else but an automaton which spreads spam. And this is probably the most simple way to automate in social media. And then there are social bots which are a little bit more complicated or more complex. They try to imitate human behavior. It's important to say that it's behavior, it's not communication. They, for example, try to sleep. Sorry, they try to simulate sleep, so inactive faces like people have on social media. They make breaks in their communication, and they also reply not instantly to something somebody else is posting, and they even try to maybe interact in or network in some way, but not on a communication level. And then we may speculate on some more intelligent bots, which imitate not only the behavior, but they imitate also the communication of humans. Actually, there is not so much proof on intelligent bots, but I will come to this later on, and also into perspective. So speaking on how to build a social bot and whether it is feasible or not, whether it costs too much or not, we actually started by ourselves to implement social bots. This honestly was one of the most funny part of our research. So because going to the dark side is always funny and also very creative. So basically, how to build a social bot is very simple. So you can build a very small software tool where you more or less use an API or crawl some content or even remote control some browser. And then you can access the data of the social media channels and react to some keywords, for example, hashtags, mentions, and so on different platforms. And you can even extend the social bot very easily by, for example, adding some kind of networking module where you start to build friendships by following people or unfollowing people. You can act or react on these keywords and also proactively send, for example, messages, pictures, and so on. So this is quite easy to realize. And to show this here on the right side for a Twitter account, for a Twitter bot, you can see that it's about, let's say, 30 lines of code in Python you need to implement to have a first working bot, which actually listens to the Twitter stream and replies on some keyword just with a hello user. So with a specific name, with answering directly to this user. But this is a very simple bot, and you can extend this part here very easily by such modules which I spoke of here, and then build a very simple but very effective bot to build a network, for example. So you start actually with a class 1 bot, so a very simple bot which can, for example, only broadcast, and then you have more complicated bots with which you can also imitate human behavior. And we did this, and we played a little bit with this, just in an ethical correct way, I promise. And we did not spread any disinformation, but what we did actually, we built 30 of these bots and let them act mostly autonomously in Twitter. And we invented a small game. And in this game, the users should be, so the Twitter community should be activated to play this game. And this was a Songmoji game where you had to encode a song title as an emoji sequence, more or less. And the sequence here is, for example, the sequence for crying at the discotheque. And always have to send this Songmoji hashtag here, so that we could detect how this trend actually worked out in Twitter. And we did this in a two-phase experiment. In the first phase, we just let our bots very autonomously work on their own. They actually started networking. They followed people, unfollowed people. They befriended with people, and they, as their only action, additional action, they retweeted content. By this, we were able in a week to collect about 1,500 followers, which really followed our bots, and we followed back. So we were friends, basically on Twitter, and they received our messages, and they were actually the community which we had to build this, to play this game with, in principle. And then we started in phase 2. We started this game by providing our bots with some prepared content, which we prepared as humans. That is the reason why we have in phase 2 here a larger human part in our action, more or less. It's always a hybrid scenario, but in the first scenario, human input was just to set up the bots, and the second one was to also provide content, and then the bots again acted by themselves. And basically, we managed to start this game, and people reacted on this game and played this game, and it lasted for about 14 days. So these people played this even after our bots were shut down. So we lighted the spark actually, and the game went on. Why we ended this after 2 days is not because we were done with spreading everything, but all our bots were actually blocked by Twitter, except one. Ralph Baum, you saw just in the first example on bot or not, or botometer. That was the only bot which was not banned from Twitter. So actually, the reason was not that Twitter detected us, but the reason was that a user detected us. So we were a little bit too eager with playing with our bots. We made them very active, and we made them so active that they liked even the posts of other users, but instantly. So after 1 second. And one user was obviously very annoyed by this behavior and felt attacked. And so he or she actually notified Twitter, and Twitter banned all our accounts. But what we learned from this is that also the indicators which I showed you were not able to detect our bots. So this is the botometer score over time. During our networking activity, it was still more a bot than not a bot. So we scaled it here from 0 to 1. So it was about 0.5, 0.6. But after we started our activities, it dropped under 0.5. So we were more human-like than bot-like. And specifically, this green line here, which is the user behavior, it dropped significantly, I would say, to a situation where this indicator would not have been would not have classified us as bots anymore. The users, however, did. So a human seems to be able to recognize more behavior or more suspicious behavior than these simple indicators. I come back to this later. This was actually a kind of type 2 bots, because all our bots slept during night and made some pauses, but they were too active in liking. Still, they were not intelligent. Intelligent bots we have not found, have not developed. There were some very early experiments by Microsoft and others, but they failed. The only intelligent social bots or kind of social bots which we can identify today are kind of chatbots. But chatbots are usually used for a very specific purpose. They usually are restricted to product or selling something. Or they are small talk bots like this replica AI. Training it to individual disinformation campaigns is probably very costly. So if you there is another way to look at social bots. So actually you can not build them by yourself and try out whether it is feasible to do this, but you can look at what is happening out there. So what we did is we looked at the market of social bots and try to find out whether there are social bots which we can somehow buy or whether we can buy some services. And this is what we first did in the dark and ClearNet markets. So maybe the first association you have when you think of bots. We found a lot of offers in these markets, as well in the ClearNet markets and the dark market. We found some relevant offers for some platforms like Facebook, Instagram, YouTube, and okay, obviously the internet broke down. Can you hear me again?
Yes, we can see you again.
And you can also see my slides?
Yes, we can see the slide.
And where did I lose you actually? So
we lost you about 30 seconds.
Okay, so maybe you have not heard about the markets then, or?
Could you please open the previous slide?
Yes, just a moment.
Uh-huh.
So it was just an introduction slide.
Yes, yes, we lost you during the slide.
Okay.
Okay, now can you hear you? We can hear you perfect.
Okay, perfect. Then I will continue here.
Okay, fine.
Okay, so we looked at the market of social bots to get a to get an idea how social bots actually are offered in these markets. And we found social bots in the ClearNet market and also in the darknet market. There were relevant offers for Facebook, Instagram, YouTube, and Twitter, actually in this order. And we found about 20% which offered liking and content sharing, so the very simple type of social bots, kind of type 1 social bot. And then we had 14% of offered fake followers, which is not really a bot service. It's just adding followers to an account to make people more popular. Then we had a kind of 2% offered intelligent functionalities, at least the service providers offered this, which was more or less chatbots and tutorials on how to make bots intelligent, but obviously nobody did this really. So you could buy books via the dark market, which is actually very interesting. Then we have 10% of herded or fake accounts, so a little bit older accounts, which usually seem to be a little bit more reliable in social media. If you try to manipulate or if you try to spread this information, you want usually to use older accounts because they are more reliable than, or they seem more reliable than new accounts. And then there were about 50% criminal bots, what we named criminal bots, which were used to, or which could be used to spread classical information security vectors, actually attack vectors, so Trojans, SQL exploits, or DDoS attacks. So actually, we did not found something intelligent there, but we found offers for social bot, also basic social bot activities. And then we also looked at the open market of software which is available and which you can, for example, get via GitHub, for example. And therefore, we analyzed about 40,000 projects which deal with social bots on these platforms, and they actually we found that all relevant platforms, we found software to attack these platforms. Most of the attacks could be, or most of the software was for Telegram, which is not surprising because Telegram is offering a dedicated bot API, and Twitter, which offers a very open API. Facebook bots, Reddit bots, and so on the other networks were a little bit more so, actually. We also found that the offer, if you classify it according, or if you partition it according to countries, you see that platforms are of different importance in different countries. So there is a correlation between their use in the countries and the offers which are available from these countries, actually. So in the United States, Twitter is very important. In Russia, for example, Telegram is a very important platform. And in India, for example, WhatsApp is a very important platform. So the social bots from these countries, which are coming from these countries, mainly attack these platforms, which are very important in these countries. What we also found is that these technologies or all this software which is there are usually implemented with prototyping languages or rapid prototyping languages like Python and Go and so on. So software which is usually used for starting programming very fast and trying something out, but not to build very highly functional software in this area. So what we see is that most of the software is in a very prototyping state as well. So that means we have development of social bots, and there are social bots. There is social bot software, so people use this software and make basic stuff with it. Actually, very simple stuff, and you can also sell these services. And from this, we would conclude that if there are services offered and people pay for this or people develop it, it is also used in social media. It's a kind of indirect conclusion. What we also see is that the commodity market from the clean and the darknet, so services actually complement the software. If it is complicated to program something, then you can find it on the markets. And if it is easy enough to implement it, you can mostly find it on the collaboration, software development collaboration platforms like GitHub and so on. So this was on social bots, and I hope on the specific topic on social bots, and I hope I was able to show you that there are at least some indications that social bots are still real. But if we broaden our view, we can look on the disinformation campaign and the campaigns themselves, and on the actors in a second step. So looking at the campaigns and learning from what we have seen, how people detect social bots, we have started to build a dashboard to look at multiple indicators at the same time. This was in 2017 when the last German general election started, and we worked together with the Ministry for the Interior, and they actually wanted to know whether there are social bots in this election active. And what we did, we just monitored the Twitter stream and just have very simple indicators. So only the posting posting numbers of accounts. We had the posting numbers of accounts over time for specific topics. And actually we found just by looking as a human at these indicators, we found some very interesting patterns. So we found, for example, this pattern here, and this pattern is an activity pattern of accounts in Twitter which post content from a very small party in Germany. And what you see is that they are permanently active, so like our type 1 bots, and they actually drop in activity every day at 3 o'clock. That is when the network is reset and all bots just be quiet for just 1 minute or so until the software reboots and everything goes on. And if we look at the accounts which are behind this activity, you can see that they're almost active in the same amount. Yeah? They are actually posting more or less the same stuff, just in different order. So these were, and we contacted these guys, and we also tried to find out what they're doing. They really posted just advertisement for this party over a longer time. And this is what the activity we saw here through 3 days, and also longer. So what we learned from this is actually that we maybe should change our perspective, that we should look on the behavior level, and that we should look on a coordinated level of multiple accounts, what they are doing together, and then learn from this whether they actually act together and whether we can extract further information in top-down manner from this. And to do this and to actually get something like these time series here, and not to detect the topics which are suspicious ourselves, we wanted to detect the topics first and then look at the importance of the topics over time. And this is what we did. We used a stream clustering algorithm so a real-time clustering algorithm over time for text. So to get a kind of clustering of content of text over time with different weights very dynamically as it develops in a Twitter stream, for example, or in other stream. And what is actually done here is that the text is put into this system. It is actually chunked, and these chunks of words and data or n-grams is actually clustered in an online fashion. So we try to assign new text to existing clusters or build new clusters if they don't fit good enough. And what actually happens then, we get these so-called microclusters, and these microclusters have, according to the amount of data which is added to them, they have a larger or smaller weight, and this weight can be observed over time. And this is a kind of importance of topics which is in this tree. So from this, we designed a kind of framework from which we expect that we could, first of all, observe interesting topics and then analyze these topics. So we have this clustering approach, producing some time series on topics, which we detect in a text stream of social media. And in this, we may observe some kind of peaks. If a topic is rising very fast and people are acting very intensively in this topic may be either automated or may be a topic which is very hot at the moment. So we can choose this topic and analyze it in a second offline step in more detail and find out who is acting there and what is discussed. And this is actually what we implemented now for the German federal election, which just happened, I think, 3 weeks ago or so. And actually, this was our dashboard. It's in German, but I will describe what is important. So what we see here are actually the different topics, and these topics are anonymized, and so to make it public for all the people to look into the into our results. Actually, what we see here are exactly these peaks, and these peaks show that the importance of a topic rises very fast, and then we can look into the details of such a topic just by clicking on an incident here and find out that, for example, a single user is very active. And we can also get some idea on what this topic is about. And in a private view for us, we can also see that there what is actually happening there, and which actor is acting very strongly and is maybe also optimized. So we can now here start to go forensically in these these details of such a rising or suspicious topic, actually. So what we may learn overall from this perspective is that it's far more informative to study the interaction of accounts in social media. It's not so important to look into a single social bot account or in a single account and try to find out whether it is a social bot or not. Because usually such accounts are always hybrid, so they are not always used by a bot or by a human who uses some kind of automation. They are usually hybrid and change over time, so it's more important to identify what the bot is doing and not that the bot is a bot or not in this moment. And if we do this, actually to look at the campaigns, then we can isolate the bots as a bycatch. So again, just to summarize this here, the disinformation campaign is actually on a macro level, and it consists of multiple tools. It consists, for example, of social bots, but not necessarily. It also may consist of trolls and human actors who are participating in such a disinformation campaign. So if we discuss on all these specific tools, social bots, trolls, human actors, we are on a micro level. But the interesting thing happens actually on the macro level. So on the coordinated or orchestrated collaboration of these micro level actors. So coming back to the initial question or the initial conflict, which is from my point of view not really a conflict. Yes, the detection mechanisms for individual accounts are really weak, but that does not mean that there is no automation, and we found several kinds of automation during our investigations, also in the German election. What the effect of this automation is actually another question. Then the automation is also, from my point of view, a logical consequence, because it's sometimes easier just to spread information via automation instead using human actors for distributing some very simple information. But definitely automation is not sufficient for running a complete disinformation campaign, at least not as long as we don't have very intelligent actors which we can reliably steer. So coming to my last slides, and only to very few perspectives and future challenges, there are definitely challenges also for bot detection or campaign detection coming with new technologies. So we can think of generative language models which create really believable content. For example, GPT-2 and GPT-3 are very interesting technologies to make it neutral. Actually, they can fool people, specifically if you have very short text. If you have long text, you may recognize, but if you have short text, like in social media, it could be used for this. You have deepfakes and images, or even deepfake movies, which you can use in disinformation campaigns. So you have more tools now to feed your disinformation campaign by real-looking content. And that is, I think, a new level, and that is something which is, again, a challenge also for detection mechanisms like our, which is looking at the collaboration of actors, but also on the content level. So what we actually need is some mechanism that looks then also for the content and can classify fake content. There is a broad field, another broad field of automation and AI and regulation. There are a lot of questions I don't want to discuss now in detail, but these are also questions which are directly linked to this topic. What is allowed? What should we monitor? Who should be allowed to monitor, and who should be allowed to have all the data? Is it the platforms, or should there also be a third party maybe who can look into this data? And what party should that be? Is it reliable? Can people trust in the sense of privacy, and so on? So there are a lot of questions which should be still answered. And then I want to have a final slide on self-propaganda, actually, a kind of self-propaganda. It's on what we are doing in our group. We work actually not only on social bots and on automation, we work also on a broader context in a very interdisciplinary field, which is, from my perspective, very fun. So you have communication scientists, you have journalists, and all the lawyers with which you have to work actually to get a broader view on this topic. And there are a lot of network activities, and you are, of course, invited to participate if you like. And there's also a conference which is very interdisciplinary in Mistum. And we also have a lot of projects on this topic, from disinformation campaign detection to teaching in the AI human rights and ethics area. So that's it from my side. I thank you for listening, and if you're interested, here are some links where you can find further information. Thank you very much.
Yes, thank you, Christian, for interesting research, interesting presentation. And I have one question. During your presentation, you have talked about the bot detection problem and stated that this kind of problem is caused by machine learning issues. And how you suggest to solve the machine learning problem in order to solve weak bot, for example, social bot detection problems? What kind of artificial intelligence, including machine learning technologies, could you recommend to put into the practice or something?
So I think there are actually two things we could address. The first thing is we could try more or less to keep pace with the development or the timely development of the development of bots. So we can always try to continue learning and try to tag new bots, new behavior, and to learn this again. So we continuously have to learn. The problem is that we don't have the ground truth. Actually, we don't know whether what is out there are bots or not. So this is a little bit unreliable. So what we probably need to do is to combine machine learning and all this AI stuff we need to classify with human intelligence. So we probably have to combine something like what we did with this topic detection and analysis later on, combine it with relearning of classes, of bots, or new features. And that is probably something where human and artificial intelligence actually has to collaborate, from my point of view.
Okay, thank you, it's clear. Do we have more questions from on site? Yeah, we have one more question from Professor Jurgita Kapučiūtė-Dzikienė from Vytautas Magnus University. So.
Thank you very much for interesting presentation. And I just want to ask how much those solutions to detect social bots are language dependent. Do we only need to consider the content, what is outputted, or there are maybe some interlanguage dependent solutions? So my first question.
Yeah, thank you very much. It's a great question. Actually, some of these mechanisms are in fact language dependent. For example, or especially the machine learning based or the supervised machine learning based approaches are very language dependent. So they work very good for English language, but they don't work very good for example, German language or Chinese or whatever. So that is actually based on the fact that they base on a very small example set of social bots, which are usually from the US. So they are language dependent, at least partly. The language indicator is language dependent. Other approaches, like these very simple indicators, are of course not language dependent. And this cluster approach, which I showed you, the stream clustering approach, is actually also not language dependent because it's unsupervised. It's just comparing the similarities of words, more or less, or n-grams. So it's not language dependent per se. It depends a little bit on what you're looking at, on what broader stream you look at, and this is then classified.
And one more question, if I can. So, since I'm Lithuanian, I'm interested in that part. So, to imitate the language, the human language, you need very accurate generative models, right? So, and you, even with GPT-3, you still cannot generate the Lithuanian language very fluently. So how do you think social bots, are they the problem only for larger languages today, or with the help of human intervention is also the problem for smaller languages? So
I think they are definitely at the moment a larger problem for the larger languages, so for the bigger languages, actually English. But there are today already very good translation facilities, also based on AI, actually, and they even correct what is not so good generated by for example GPT. So I think the merging of a lot of language technologies which happen at the moment, or which come up at the moment, will in the end lead to a very mighty tool for the propagandists, actually, for the guys who spread this information to attack us. Also in every language, even without being able to speak this language.
okay, thank you very much.
Okay, thank you. More questions? Oh, please come here, because according to COVID-19 policy, it's not allowed to use the Wi-Fi microphone. So.
Hello. So thank you very much for your presentation. It was very interesting, and I wanted to ask you one more question, which is maybe out of your research scope, but still I wanted to use this opportunity. So let's say that you find those bots. So you, for example, invent a means to find them. What then? Because social networks are very reluctant to remove those bots, and even if you report the content, so usually if it's not in English language, social networks do not remove that content because they do not have enough means to automatically recognize that if it was dangerous content or not. So what are your thoughts about that?
Yeah, that is a very good question. Actually, you are completely right. It's very tedious to inform social media platforms about these social bots or these actors. Actually, it could also be trolls. But and we also found this out by ourselves during this German election, where we notified Twitter, for example, and Twitter reacted. But Twitter reacted very reluctantly, and that is actually a problem. And I think we cannot, at least as scientists, we cannot directly force in some way Twitter to do something. You can, we could maybe as a society try to regulate this in a way, and there are already some regulations, but probably the time to react on something like this is still too long. Yeah, so disinformation may spread in this time until somebody reacts very far. I think one countermeasure which we can try to implement is actually to make these campaigns in some way transparent, to have something like this dashboard, which we had in a very small, which we had now in a very small setting for the German election campaign, to have it public and that everybody can look into this dashboard and can see what happens there and what is detected. I admit that understanding everything in these dashboards is not trivial. So we probably have to also work on how to communicate the results and to make them accessible for not scientists, to have a kind of transparency. I think that is maybe not the best way, but it's one way to start.
Thank you very much.
Okay, thank you, Christian, very much for presentation. Thank you. And now, according our schedule, we'll have 30 minutes coffee break, and we'll return at 11:30 a.m. Okay, thank you, and hope to see you after coffee break. Thank you. So, good morning, colleagues. Welcome back to the 27th International Conference on Information and Software Technologies. Now we'll start with session number 4, Business Intelligence for Information and Software Systems, special session on intelligent methods for data analysis and computer-aided software engineering. And the first presentation titled Investigation of Recurrent Neural Networks Architectures for Prediction of Vessel Trajectory. Presenter we have online colleague Robertas Jurkus. Can you hear me?
Yes, hello, I can hear you.
Okay, great. So could you please share your slides and you can start?
Yes, of course.
And
Yes.
the time limit about 15 minutes, okay?
Yes, okay.
Great.
Okay. I hope that you can clearly see my slides.
Yes.
Okay, then I will begin my presentation. So thank you for the introduction. So my topic for the research sorry, I will. Okay. So my topic for the research is investigation of recurrent neural network architectures for prediction of vessel trajectory. And the article was written together with the authors Povilas Treigys and Julius Venskus. I'm not sure if the screen is not okay. So firstly, I will introduce about and talk about the subject of the area and the issues. So in the increasingly intense maritime traffic, many ships being loaded and unloaded in ports. So information on the whereabouts of shipping vessels, their trajectories and final destination is crucial for maritime safety. For example, International Union of Marine Insurance in the yearly report announces that they suffered losses due to various incidents, such as poorly trained crew, equipment failures, weather conditions, and about 10% they suffer losses from various collisions and crashes. It's about 10%. So by forecasting and predicting the trajectory of a particular vessel, it would be possible to assess the risk of a collision or identify the abnormal behavior in the ongoing traffic. For that task is used machine learning, but traditional machine learning, like for example, feed forward, are not suitable, especially in long vessel motion sequences. So the goal for this task is to research and compare different recurrent neural networks with specific size combination of cells to predict future vessel movement. And this is the regression task, so-called multivariate multi-steps. And firstly, I will talk about the data and later about the architectures. So based on the global terminal operators in 2019, the research region with the highest traffic flow in Europe were selected: the Netherlands region, the North Sea, and the part of the Netherlands. The data for this region was collected and extracted from the ShipFinder automatic identification system, known as AIS. Basically, it's the vessel tracking in the sea by the network stations. So it's just collecting data from the vessels. And specific cargo types cargo vessel type was chosen because cargo ships are one of the most popular and most commonly found types of industrial vessel. And for deep learning algorithms, it is important that the data amount is important. So totally was collected almost 5 months data. So it's more than 20 million records. And the main vessel feature set consists of geographical positions, movement speed, movement direction, time step in minutes. So this value show when the data was collected in minutes. The data delta latitude and delta longitude is the fine-tuned features. It is calculated and derivation of existence vessel features, and it shows how fast vessel move in the time step. And here you can see how the data structure is looked in 3-dimensional. So we have sequences, vessel features, and time steps. The data from the collected system was raw data. So before using them, it must be analyzed, cleaned, structured, and pre-processed. Basically, we constructed fixed length input and output matrices from one long sequence. The training sample is used to create models on each architecture. So, for example, here we have one long sequence, and we split into fixed length, and that sequence we split into 2 parts. One is the input and one is the output. Data was normalized in range of 1 and from 0 to 1, because purpose of this was done because calculation speed and of course data normalization. Also, after the data was split into parts, into sequences, we shuffle these sequences and divide into training, validation, and testing samples with ratio 70, 15, 15. So for training, for architecture training, we're using 70% data. For testing, we use 15, and for validation, we're using 15% of data of all the sequences. And here, and now we have the data. Now I will talk about the architectures where we are using this data. In this research, we study recurrent neural networks, and all activities in recurrent neural networks are repeated, unlike standard feed-forward neural networks. In short way, it is called RNN architecture. RNN network transmits information repeatedly from one block to another, and it has feedback links and a special memory management structure called cells. So these structures is cells in each architecture, and here it is all the studied architectures. It is 6 architectures: simple recurrent neural network and gated recurrent neural network visualized here. The main difference is the cell structure. So the simple recurrent neural network use one cell structure, gated recurrent unit use another cell structure. So and each architecture have basically the same structure, such as input, hidden layers, and output layers. So we push our data by the inputs, we do the calculation, the algorithms of the recurrent neural networks, and we get some output sequence. Also, we have a long short-term memory architecture. You can see that diagram here, and this is the vanilla called sometimes, and it has one direction into one side. And another architecture is bidirectional LSTM, long short-term memory, which has both directions in both sides, in forward and backward. Also, stacked long short-term memory architecture. The structure consists of more than one hidden LSTM layers, and autoencoder is a special type of neural network in which the input is compressed into a smaller dimensions code called latent space, and the compressed code at the output of the reconstructed. So we have 6 architectures. And here, just for example, how cell structures looks like in a different type of architecture. The main point is how they perform calculations and control data flow between cells. So as you can see, the simplest is simple recurrent neural network, then recurrent neural network cell, then LSTM cell have 3 gates called input gate, output gate, forget gate, and gated recurrent unit have reset gate and update gate. So I'm not going now very deep into these cells and calculations, but just want to show you how it looks like. So we have the architectures, and to show the scale of this study, I can mention that totally we created and evaluated about 720 models on our data from the test sample. The accuracy of the network is calculated by the root mean square error, which estimates the predicted and actual values. So here we have input, output of a vessel trajectory, and we get the predicted sequence from the recurrent neural network. Since our goal and attention is on trajectory, that's why we evaluate only geographical position, which is latitude and longitude. The MSE mean square error loss value is calculated as the average of a total number of experiments divided by 10, because we trained our networks not once for better reliability of results. So we have 6 architecture, 12 cell size hyperparameters of a network, and we each model trained 10 times. So in fact, totally we have 720 models, and this is the average of the results. And as you can see, and in regression, the prediction is considered accurate when the error value is closest to 0. So the best architecture is that whose result or error value is nearest the 0. So such as architectures is gated recurrent unit, autoencoder, and bidirectional LSTM with some specific cell size. And the most accurate is bidirectional architecture. And a random sequence was chosen for the network's testing. The results are visualized with the best cell size fit. And here you can see all 6 architectures, the same trajectory, and 4 colors. The blue line indicates the input sequence, So that line we push into our architecture. The original vessel output trajectory is marked in green line, so the green line. The yellow line visualizes the predicted sequence in each architecture. And the gray lines here, this is the Netherlands rivers near the North Sea. The gray lines indicates the traffic intensity from the other sequences. So in most perfect scenario, the yellow line should be equal to the green line. And anyway, we can see that we can notice that some of the architectures make a better prediction when comparing to the others. And these three better results is at the bottom. So conclusions would be of this research that to achieve the set goal, sixth most popular recurrent neural network architectures were select sequences where information is managed by specific cell structures. And the research found that different choices of a cell size have a direct relationship to the results. Almost all architectures generate a larger error with a smaller number of cells. Maybe unless bidirectional architecture is less even with a smaller number of cells, as we can see in these diagrams. So if we have a smaller size of cells, our variation is quite big, unless what here is bidirectional architecture. So it is important to choose properly size of that hyperparameter. It was determined that the most accurate prediction and least error loss achieved with the bidirectional and autoencoder architectures. And the following studies are performed based on these results. These architectures are selected for future analysis to increase the prediction accuracy. Also, we plan to test our architectures on different regions and including more vessel types into our dataset, not only one, like we did in this research. So in general, we will keep trying to find ways how we can improve predictions using machine learning solutions, because the possibilities of adapting these kinds of architectures are not only limited to maritime traffic. So yeah, so thanks for the attention and ability to publish these results on this conference. Thank you.
Okay, thank you for interesting presentation. And I have one question. If I understood correctly, you are not satisfied with the results of forecasting accuracy. Yeah. And plan to improve them in the future. So my question is, what specific steps do you plan to take in order to overcome this challenge?
Yeah, we planned for the future to use a new architectures of a neural network. It's called transformers. They are with specific attention mechanisms, and also take deeper into the data. Maybe clustering the trajectories, because some vessels moving forward only, and some of the vessel trajectories just surrounding, and that can be like a noise in the prediction.
Okay, thank you. More questions from on-site participants? No questions. Maybe we have questions from online participants? No? Okay, thank you very much for presentation. And Next presentation is titled RTCA Analysis, Practical Modular Performance Analysis of Automotive Systems with RTC. So we have presenter online, yeah, Mahmoud Bazal.
Yeah,
Can you
right.
hear me?
Yeah, that's right. Can you hear me?
Oh, yes, perfect. Could you please share your presentation? And time limits, it's up to 15 minutes, okay? Great. So you can start.
Yeah, I hope you can see my screen now.
Yes, we can see.
Right. So yeah, so thank you very much all for attending this talk. My name is Mahmoud Bazal, and I'm a research assistant at Dortmund University of Applied Sciences and Arts. Today I will be presenting our timing analysis tool, RTC analysis, that we use to perform modular performance analysis on automotive systems. And this tool uses, as the name suggests, real-time calculus. So first, let's go through an agenda of what we are going to present today. First, we're going to have an introduction into the problem we're trying to address with this tool and why we created this tool. We're going to have a short example on how this tool works and how it transforms automotive models into RTC models that we can use to perform timing analysis. We are going to look at the evaluation that we have conducted, which is based on industrial models from the automotive domain on 3 different levels of abstraction. And finally, we're going to look at the conclusion and the future possible improvements to this tool. So, as you can see in this picture, in these pictures here, we have multiple pictures that show different scenarios that involve autonomous driving. So we know that in many modern vehicles, we have these autonomous driving or advanced driving assistance systems. And the nature of these systems mean that that they are heterogeneous in 2 ways. They are heterogeneous in terms of hardware and in terms of software. So when we talk about heterogeneity in terms of hardware, we talk about multiple components in the vehicle, multiple subsystems in the vehicle. They're all talking to each other. They are all communicating with each other, but they can have different models of computation or different rates at which they process data and so on. And on the other hand, we have the functional domain heterogeneity, which is mainly on the software level, where you have where we can have multiple software applications running on the same system or even the same hardware platform, which some of these applications are safety critical and some of these applications are not safety critical. Safety critical, for example, things like ABS systems and airbags and emergency braking systems. And non-safety critical are things like infotainment systems, navigation, and so on. So the focus here is on the safety critical systems. So for example, if we look at this picture here, we can see an emergency braking system. So the vehicle is moving, it detects an obstacle in front of it, and then it has to brake. But it has to brake within a given time limit in order for this system to be considered safe. Now, how to make sure that this time limit is not going to be exceeded during the runtime of the system, during the car being just driving on the road. So in order to do this, we conduct timing analysis, static timing analysis. There are many approaches to do this, where we model the software and the hardware, and we consider what possible timing constraint violations are there. So there are many timing analysis approaches. So for example, compositional performance analysis and other holistic timing analysis methods. However, all these timing analysis methods are complicated in that, I mean, mathematically they are complicated and they're non-modular, so we can't use the same analysis method for many systems if we have heterogeneous systems. So we are focusing on heterogeneous systems and modular systems, as the industry focuses on these things too. So in order to address this, we want an analysis technique that is modular and also supports modular systems, meaning that if we change one component in our system, we can still have, we don't have to reconduct the analysis again, reanalyze the entire system. We can just change it with a new system, as long as the input and output constraints are still satisfied. So here's where RTC comes into consideration. RTC allows this real-time calculus, and also we implemented this into the tool. So now it's going to support automotive systems. So in order to do the timing analysis with RTC, we need some sort of an automotive model, and our tool interfaces to the Amalthea model. So the Amalthea model is a part of the Eclipse App for MC tool platform. It's a tool platform that is used in the design of automotive systems and also in data exchange. So this tool platform, we can do many things. We can do software modeling, we can do hardware modeling, we can do operating system modeling, constraints modeling, and so on. And we can do multiple things on these models during the design phase of these automotive systems, like simulation, like optimization of what is the optimal deployment of hardware to software, and also partitioning, grouping multiple grouping functionalities together. So all of this is centered around this Amalthea system model, and we use this system model to convert automotive models or automotive systems into RTC models. Then those models we can use to do the timing analysis. And now we're going to see how we do that in an example. So I thought of a very small example here. There's for the sake of time, there is a more complicated example available in the paper. So this is a very simple example of one processing unit that has 2 tasks being scheduled on it in real time. And this is how it would be modeled if it was in an automotive system. In the RTC analysis tool, we start considering each element of this model and what is the equivalent of that in real-time calculus. So we have, first of all, we have these 2 tasks here, and the 2 tasks are periodic, meaning that they repeat or they get released with their periods. So if one has a period of 11 milliseconds or 11 time units, it's going to be repeated every 11 time units, and so on. So in order to model this, we use the arrival curves from real-time calculus. So arrival curves just represent how many releases of a given task or how many events have happened within any given time period of a given length. And this given length is here. So for example, in a time period of length 14 units, there will be at most 2 releases of this task, and at least there will be 1 release, and so on. So we do this for these 2 tasks, and then this also will help us model the computational demand. So how much computational demand is required from the system or from the hardware resource. And now we model the computational capacity of the hardware resource with this curve here. This is what we call the service curve. And the service curve just models, let's say, for example, this processing unit processes one instruction per clock cycle, so that you can see it here. It's linear. So if you have more clock cycles, you have more instructions. And we have also upper and lower bounds on this, and the actual service or the actual computational capacity could be somewhere in between. Now we want to model how the scheduling is going to happen. So this scheduler here is a fixed priority preemptive scheduler, meaning one task has a higher priority and the other one has a lower priority. So how do we model this? We model this by creating these greedy processing components for each one of these tasks. And the greedy processing component for the first task, let's say with the one that has a higher priority, receives the entire computational capacity from the processing unit. And then what remains of that is being given as the computational capacity available to the second one. And what remains of that is what remains of computational capacity of this processing unit after processing these two tasks together. In the same way, we can conduct the GPC transformation, and then we transform these arrival curves from the number of events, number of releases of a task that happened in a time window, to the number of finished tasks in a time window. And from the comparison between these curves here, we can derive timing matrix. In this case, we have timing matrix such as the best case response time and the worst case response time of these two tasks that we started with. So through this entire workflow, we started with a model like this, and then we got analysis results or timing results like this. So now let's come to the evaluation that we have conducted. So we have considered 3 automotive models, 3 industrial models, on 3 different levels. We started with we started a model that has a single core and 3 periodic tasks. That's a very conceptual model that we started with to evaluate the tool. And then we have considered an engine management system, which is very close to the actual implementation. How it is implemented. So you can see that there are about more than 1,200 software elements that are being modeled here. And then also we considered a high level functionality level ADAS application that also what happens there when you have data flows. This is very important. So you can see here this example here. This is from the Waters 2019 challenge. Again, you can refer to the paper for a larger description of this. So we have different tasks, and they're all passing data to each other. So you have a stream of data for this autonomous driving application. And we have this, and we have shown here how many GPC elements are there once we do the conversion to the RTC model, and how many data flows that we can see here. Also, we focused on comparing the runtime of our tool on these different models. So we have 2 different algorithms to conduct the RTC analysis. We have direct RTC analysis and finitary RTC analysis. They differ in their time complexity as algorithms. We have compared the analysis runtime versus the number of GPC elements created from the Amalthea model. We have compared the analysis runtime also with the complexity of the RTC model created. And the complexity, this means mainly the existence of flows in the system, like this one here. So here, sorry. Yeah. So here's one evaluation that we have conducted on this engine management system that I have mentioned, and here we can see that we can show the worst and best case response times of these tasks, as well as, I mean, for comparison in this visualization, we also have the execution times of the task, just to compare from the execution time how much it increases with the response time. So now here we will look at the analysis runtime. We have a few different comparisons. So we ran these 3 models with direct analysis and with finitary analysis, And we can see here that for small models, this demo card, this is the conceptual model. For the small model, you have we have, even though finite tree analysis for more complicated model is much more efficient, it has a certain overhead, meaning that for smaller models, it's not it's not worth it. The direct analysis is faster. And the same thing here, and you can see here, even though this model Waters 2017 is the model with many software elements, even though it has many software elements, it's a very large model, we still have a reasonable runtime of about half a second with the finite tree analysis. We have given in our tool the choice to the user, depending on their model, whether to use this one or that one. So to conclude everything, the RTC analysis tool performs modular performance analysis on advanced automotive systems. It's all based on RTC, real-time calculus. The tool gives us the option to derive various timing metrics. Right now, the timing metrics that we have are the response time in best and worst case, and the number of deadline misses in best and worst case. And the RTC models that we create are modular, meaning that we can use them, we can reuse them to simplify timing analysis, especially for heterogeneous embedded systems, where we can take one component out and swap another component in without changing the analysis. RTC analysis, as we have seen from the evaluation, is feasible for real models of automotive systems and on various different levels of abstractions. Finally, in the future, we are aiming to derive additional timing metrics. Now the timing metrics responses and number of deadline misses, but we aim to derive more timing metrics, such as number of preemptions for a given task, context switching for schedulers, resource loads, and so on. We aim to extend RTC analysis to support probabilistic RTC, which means we will consider the statistic aspects of a system. Now we are working with fixed numbers, but we can consider all these statistics and aspects of a system, meaning that execution time may have some sort of a statistic distribution. The processor capacity also can have different values, meaning that it follows a statistic distribution. So we aim to address that with RTC analysis, and we aim to also support additional models of automotive systems, but also RTC can work with non-automotive systems, such as the Rubus system model that we can use, that is used for modeling avionics applications, for example. So that's it for my presentation. Thank you very much for listening. And if you have any questions, yeah.
Okay, thank you for presentation. And I have one question. What else is missing to put your solution into practice in a real vehicle? For example, what percentage of your work has already been done and how much remains?
Much of it is done. The analysis is done, and it is open source, so you can access it right now. So this is a part of the design process. So this is not something that happens when we are on the implementation level. This happens when we are on the design level. When we are trying to design the system, we have to guarantee the timing requirements. We use this tool, and now it's being used in the context of the research project Panorama, and it is implemented in terms of cloud service. So you can access it. You can access it in the cloud. All you need to do is upload an MLThea model, and it will be fine. You upload the MLThea model, and the analysis will be conducted.
Okay, it's clear. Thank you. More questions? Okay, we have no questions from on-site participants. Do we have questions from remote participants? Okay, no questions. So thank you very much for presentation. And now we'll have next presentation named Runtime Class Generation Algorithms for Difference of Homogeneous and Inhomogeneous Classes. So the presenter It's Dmitro Terletsky. Dmitro, can you hear us?
Yes.
Great. We can see you. We can hear you. So could you
Great.
please share your slides, and time limit is approximately 15 minutes, okay?
Yes, okay.
Great.
So could you see my screen?
Yes.
Okay, let us begin. My name is Dmitro Terletsky, and I'm the researcher in Viktor Glushkov Institute of Cybernetics of National Academy of Science of Ukraine. And I want to represent some results of my research, and this is my presentation related to runtime class generations and algorithms for difference of homogeneous and inhomogeneous classes. So here you can see the short agenda of my speech, and let us begin from the introduction. Here you can see the general architecture of knowledge-based system, and this is the main components of the system. We working on the construction of such systems, and especially currently we work on the integration step, integration engine, and it is important part of the knowledge-based systems because when we extract some new knowledge from the domain or from acquire it from experts, we need to integrate them somehow in the knowledge base. And it is not a very easy task, because if you have some knowledge which were previously integrated into the knowledge base, and we want to add and integrate new ones, new items, new knowledge items, we need to check do we have the same knowledge previously or not? Are they similar or not, and so on? And how the new knowledge item will affect the previous ones. So, and my presentation focused on this step of knowledge-based system, I mean knowledge integration. And here you can see the main goals which we want to achieve during our research. First of them, we want to develop some algorithms for implementation of basic set theoretical operations for object-oriented knowledge representation structures. When we say object-oriented knowledge representation structures, we mean classes, objects, relations, and so on. And finally, we want to provide a tool for runtime generation, analysis, and integration of such structures. So here is the definition of what is the knowledge integration given by Kenneth Murray, and it describes generally the idea of knowledge integration. And here you can see the computational model proposed by Murray and his colleague Porter, and this computational model consists of three main activities. First of them, it is recognition, when the system, knowledge-based system, should recognize new relevance of the new knowledge items with the previous with those knowledge items which was previously integrated into the knowledge base. Second step is elaboration. In these steps, the system should evaluate how the new knowledge items can affect those which were previously integrated. And the third step is the adaptation. It means the integration new knowledge items into the knowledge base by resolving all inconsistency, conflicts, and so on. And we use this general idea of knowledge integration process in our research. So here you can see the more detailed part of the knowledge-based system, especially integration in gene. And for integration of knowledge items, they should be analyzed before they will be integrated. And this analysis is not very easy or trivial task, because if we have a huge knowledge base, we need to compare each new knowledge item with items which were stored in the knowledge base. And then if we can integrate them without any errors in the future, I mean inconsistencies during the reasoning and so on, we can do it. If not, we can analyze and try to decide what should we do with these knowledge items which were put it in the input of the knowledge-based system. So and here I specified a few most important knowledge analysis problems. It is analysis of knowledge relevance, when we need to understand other new knowledge item relevant to the previous ones or not, and it means are they represent new part of knowledge or not, or it is the same domain. Second one is the knowledge equivalence, when we try to understand is the two knowledge items equivalent ones or not. And the next one is inclusion, similarity, and difference. And it is not the completed list. So here is just the most important, for our opinion, knowledge analysis problems. And currently we are focused on the knowledge difference, when we try to analyze new knowledge items, compare them with the previously integrated ones, and calculate are they different or not, and if yes, we want to compute this difference and use it for integration these new knowledge items into the knowledge base, avoiding the representation redundancy and different kinds of conflicts. So here you can see the more detailed scheme of analyzer within the integration in gene. So when the representational engine maps the knowledge items in terms of knowledge representation model chosen for particular knowledge-based system, we need to check, we need to done all of this kind of analysis to understand the meaning and not meaning. We need to understand how these new items are affect or how they relevant, how they similar, equivalent, or different from those one which were integrated. So, and in this presentation, I will focus on the difference analyzer, which allows us to compare two knowledge items in terms of classes of objects, and after that compute this difference if it exists. So Here you can see the main representation structures within object-oriented knowledge representation approach, and such structures are objects, classes, meta-classes, and relations. Here we use two kinds of classes, homogeneous and inhomogeneous. Usually, most of object-oriented representation models used just homogeneous classes of objects. The same situation in object-oriented programming. When we say homogeneous class, we mean that all objects of such class have the same structure and have the same behavior definite within the class, and these homogeneous classes define single types of objects. And when we talk about inhomogeneous class, it is more complex structure when one inhomogeneous class defines some set of types of objects. So let us consider more detail these two kinds of classes before we consider the main results of our research. Here you can see the example of homogeneous class of objects represented in terms of object-oriented dynamic networks. It is knowledge representation model proposed as previously, and it is similar a little bit with the object-oriented programming. However, there are some important difference. This model uses two kind of properties or attributes, qualitative and quantitative. And here you can see the P5, for example, it is a qualitative property, and for example, P1, P2 are quantitative properties, and qualitative properties, it is like something similar to the predicate definite over the quantitative or other qualitative properties or even methods. And also this model use concept of method, which is very similar to those which are used in the object-oriented programming and other object-oriented models. And this example describes defines this example represents the class which defines the concept of rhombus. It's a figure, and this is the simple representation of this figure. And here is the idea of inhomogeneous classes, and the trivial concept is the single core inhomogeneous class, and more general is multi-core. And here's the picture which helps us to explain what is what is multi-core inhomogeneous class of object is. From the left side of the picture, you can see the classes of objects, which defines some types of objects, and we put it some colors to depict similar parts or equivalent parts for between these among these classes. So and it means that there is some intersection between these classes, and in more directly they have some common properties or attributes or methods or both of them, and to represent such structures, knowledge structures, in more efficient way, we proposed multi-core inhomogeneous class of objects. And here you can see from the right side of the picture the multi-core inhomogeneous class of objects, and the yellow square means the core of level 4, because we have four homogeneous classes, and this part is similar for all of them. And we have two cores of level 2, because this one orange core is similar for first one and third one, and we have also the blue one, dark blue, which is core also of level 2, and it consists of methods or properties which are similar to for the second and fourth classes of objects. And this blue, it is the projections of the age of classes, which means the properties and methods which are typical only for a particular class. So, and this is the main idea of inhomogeneous class of objects. As you probably understood, it is possible the situation when we will have not just 3 cores, it can be more, 5, 10, and so on. And here is the particular example of such inhomogeneous classes, and it is the class which defines 3 types of geometric figures. It is squares, parallelograms, and rectangles. So, and here you can see the core of level 3, first core of level 2, second core of level 2, cores of level 1, and projections. And all these cores define some common set or sequence of properties and methods for particular types. And as you can see, they have different combinations, and it is the main difference between multi-core and homogeneous classes and hierarchies of classes which are used in object-oriented programming, because the inheritance mechanism which usually we can use in object-oriented programming does not allow us to build such compact representation. And there are some problems with inheritance mechanisms, so therefore we used such representation. And here I put a few general definitions. What is the runtime code generation, and the more specific task runtime, here should be class, runtime class generation, when the system dynamically generates new classes of objects in the runtime, use them, execute them, modify, and so on. And also, I put it the definition, what is the exploiter. We used such concept as exploiter of classes. It is the special functions which use the classes of objects as a parameters for construction of new classes of objects, and it allows dynamically. It allows the system dynamically generate new structures, knowledge representation structures, and we proposed the concept of difference exploiter for 2 classes of objects, when first class T1 and second T2 can define some sequence of types. Each of them can be homogeneous or inhomogeneous, or both of them could be homogeneous ones or inhomogeneous ones. And we need to consider 4 cases, because the difference operation is not we need to, because T1 minus set minus T1 and homogeneous is not the same as vice versa. So we need to consider all these cases. For the homogeneous classes, when we need to compute the difference, we proposed the algorithm in the previous research. So in this time, we considered just these three cases, and we proposed three algorithms which difference of homogeneous and inhomogeneous classes, inhomogeneous and homogeneous, and difference between two inhomogeneous classes of objects. All these algorithms are described in details in our paper, so you can find more information. And the main idea of the algorithms to check the equivalence of qualitative, quantitative properties and methods of the class, and in this way to check the equivalence between some subclasses of classes. And as a result, algorithms construct homogeneous or inhomogeneous class of objects. The result depends on the particular case which we try to which we analyze. I mean, if we have one of these cases. So, and it also the result also depends on the heterogeneity of the classes and the number of equivalent properties or methods. And of course, it is possible the situation when two classes of objects will be the same, and the difference in such situation, difference does not exist. But if they have some common properties and some in common properties, such difference can be computed in the terms of some homogeneous or inhomogeneous class of objects. And what we can do with this difference, we can use this approach to analyze the difference between new knowledge items and previously integrated into the knowledge base. And if the difference exists, we can conclude that new knowledge items represent some new knowledge pieces for the system, and they should be integrated into the knowledge base. And in the same time, if the difference exists, we can conclude that there are some common parts between particular new knowledge item and some knowledge item which was integrated previously. And we can use this information for the proper integration such items into the knowledge base using concept of multi-core and homogeneous class of objects. And it allows us to avoid redundancy, representational redundancy. And it allows us to make the integration process more efficient in this way. So and finally, here's a few. Here you can see a few references of our previous research, where you can find more information. We presented similar algorithms for intersection, union, and decomposition of classes, and using all these algorithms together with the algorithms for difference of homogeneous and homogeneous classes, we can develop some tool which allows this knowledge-based system dynamically generates new knowledge representation structures. It's from the first side, and second point it is that we can analyze the new knowledge item and compare them with the previously integrated, and it will help the system to integrate new knowledge items in the proper way.
Okay, thank you, Dmitro. We are short in time, so thank you for your presentation. And do we have questions from on-site participants? Okay, I have one question. I want to ask a practical question. What platform or framework would you recommend for knowledge storage and processing? We know that there are open source knowledge repositories or knowledge engine solutions like Amunda and others, and is it possible to use them for your proposed solution?
Thank you for your question. Everything depends on the knowledge representation model, because each model defines some specifics and propose some knowledge representation structures which we need to use using this model. So we propose this approach for the object-oriented knowledge representation. So it means that all object-oriented models can use this approach, maybe with some small adaptations. For example, we also working on the adaptation these ideas for the object-oriented programming and integration them into the programming language such as Python. So when we construct the tool, we can share it as open source, for example, and use it for different systems. And generally, my answer to your question is everything depends on model.
Okay, it's clear. Okay, thank you very much. Thank you very much, Dmitro. And next presentation will have titled The Applications of Z numbers in Delphi method, and the presenter will be Arkadiusz Banasik. We will. Yes, we can see you, Arkadiusz. We can hear you.
Okay, I will share my screen. One moment.
Yeah, we can see you.
Okay, and what about
we can see the slides. Okay. Time limit 15 minutes. Okay.
Okay, no problem. Thank you very much. My name is Arkadiusz Banasik, and I'm representing Silesian University of Technology. In 2019, we were present at the ICIST in Vilnius, and we were talking about Z numbers used in Delphi method, and it's a continuation of our research. So let me start from the agenda. A short introduction, a little bit of preliminaries, the description of methods, and example, and of course conclusions for the rest of the presentation. So let's start from the introduction. The humans are such kind of creatures that have to forecast and interpret events even if we do not have a full knowledge about the phenomenon or a process. That kind of phenomenon is defined, for example, by forecasting for decision making. For example, even if in a case of overtaking the car in order to speed, distance, and so on. So to make the safe decision, it's not needed to know all the exact speed, distance, not to qualify the set. You may use the linguistic variables such as fast or far if we don't have the exact number, exact data to cope with. And that is, generally speaking, the way the humans are thinking, the humans are solving their problems. So we were focused on the Delphi method, which is used to use the knowledge or experience and opinion of experts from specified field. And it takes usually several stages of evaluation in the process connected with the feedback. And of course, the very important part of our decision-making method is the feedback. The feedback is based on consideration of the ratings from previous rounds by experts, for instance, some kind of arithmetic mean or other descriptive statistical measures. That feedback can modify the rating to be closer to the aggregated value. So it's necessary to look through the main preliminaries that we used during our research. The first is fuzzy set. It's normal definition made by Zadek, so I won't describe it more precisely. The same situation is the membership function that can be defined in many ways, but in our research right now, it was a trapezoidal membership function. Of course, according to those two things, when we are using numbers, we are using fuzzy numbers in which we can define them in such way that you can see on the slide. Of course, very important process for our research is the defuzzification process, that we convert the fuzzy value into the crisp value, which is very important in numerical examples or in practical use. And that is one of the methods, the gravity center of gravity method defined by the formula on the slide. And of course, there are many other approaches that can be used to describe the fuzzy set. For example, the bandwidth, which is an interval form, and we use it during our research. I will explain a little bit later why we are talking about those preliminaries, because it is connected with our previous studies about decision making and using, of course, the Z numbers. And of course, we can define the Z number as a pair of fuzzy numbers, where are two very important pieces: the bound of real variable x and the measure of reliability, which is very important in our case if we use the expert's knowledge to combine with the reliability. So there are some operations which are necessary to be made on the Z numbers, and there are, for example, the arithmetic operations, and you can use it in the way that you use the bandwidth, and it will produce the fuzzy numbers which will be used during our method. And of course, very important thing, the conversion of Z numbers. We can use the trapezoidal components can be converted into a Z number by the formula you can see on the slide. And let's start with the method. The Delphi method using Z numbers is based, generally speaking, on the expert's feedback in the form of Z numbers. The information is expressed in the opinion, and it's aggregated and sent back to the experts. And the next round of the expert opinion starts taking account the aggregated information from the previous round. And the step is repeated until the satisfactory opinion is reached. So it's necessary to make it as much time, we spend as much time as we need to have the satisfactory level of opinion reached. So in the Delphi method using Z number, an important step is that method uses the aggregated expert knowledge to work on the typical prediction value. This article is generally focused on the arithmetic mean of Z, of consecutive Z numbers Zi. So it's to find the value, we propose the formula with a little bit modification. So you can see here the suggested value of arithmetic mean might look like this. It's one of the options, and we focus on that because of those things that first of all, steps. Experts declare their opinion, giving the trapezoidal numbers A, B, C, D, and the reliability. And of course, is the component reliability is defined in the range between 0 and 1. The fuzzy average of expert rating is calculated according to the formula on the previous slide. Then the value is converted into fuzzy number with the previous preliminaries that were presented. And that step opens another evaluation round. So the steps are repeated until the value of Z is stable. And of course, the last step after gaining the stability is to convert the Z number into a crisp using the formulas from the preliminaries. And of course, each time we replace Z number with corresponding fuzzy number, some information is lost. That was the main disadvantage of the previous method presented in 2019 in Vilnius. So we were thinking about how to solve it. And the situation, as I mentioned there, is undesirable. And the better solution is to perform the calculations directly on the Z numbers and return the experts a value that is a fuzzy number. This approach was presented in the paper that was sent here to Kaunas. So let's look through the numerical example. The manufacturer is taking into account the production costs of adequate margin and is interested to learn how the price should be obtained. He proposed $10, sorry. And he invited 4 experts to find the best price in their opinions, and those proposed price are shown here in the table. About 11 very high, of course, those is reliability. So about 11 very high, about 10 very high, about 10 high, about 9.75 very high. We can show the reliability levels in the form of fuzzy trapezoidal numbers, and it's shown in that table. And we can exchange those experts' proposals into numerical form, and that show the table. We counted the arithmetic mean according to the previous formulas. And we start with the second round of the opinions, which they based on the previous arithmetic mean of Z numbers. And after that, they change a little bit their proposed price, also shown in numerical form. And next time, the arithmetic mean is counted. And in our opinion, that Z number was on the satisfactory level. So we counted those crisp value from that Z number, and the price should be $9.93 US. So according to our point of view, the article discusses the modifications of Delphi method. It uses the Z numbers, and the Z numbers are used in experts' opinions. So the presented modifications assume that the direct use of Z number arithmetic is more efficient, and the loss of information is less than in previous researches, and that's the most important benefit of using the trapezoidal fuzzy numbers. And of course, the operation process is illustrated by the example of determining the price of products. And our further work will focus on specific areas of application of the proposed variant, not only the numerical example, but to find the practical use of it during our research. Thank you very much for the presentation.
Okay, thank you very much, Arkadiusz, for presentation. And I have one question. So if I understood correctly, this approach means that some information is not lost during recalculations using Delphi method, yeah?
Yes, exactly.
Yes, so could you name the percentage or some other quantitative units of measure of amount of information
of the information
that is not lost? Yeah.
Okay. I need to extend it a little bit. The first method was based on triangular fuzzy numbers, and the percentage of loss was about 20%. And after changing those attributes towards trapezoidal fuzzy numbers, it's about half of them, 10 to 12% of loss is. So we gain 8%, and in my opinion, it's a huge amount of information that we do not lose.
So it is significant results in your research, I think. Okay, thank you. More questions? Okay, we do not have more questions. Thank you very much for your presentations. Thank you. And the last presentation of our session is titled TMBUD, a data set for urban SEN building detection. So the presenter will have Cyprian Orhei, yeah?
Yes. Can you hear me?
Okay, great. We can see you, we can hear you. Could you please share your screen?
Now it's my screen visible.
Perfect.
Okay.
Yeah, perfect. And time limit 50 minutes if possible, okay?
Yes, of course.
Great.
Hello, everyone. First of all, my name is Cyprian Orhei, and today I would like to present our proposed dataset, TMBUD, that comes from Timișoara Building Dataset. It's a dataset specific for urban scenario building detection, and the paper we submitted was done by me and my colleagues Silviu Vert, Mogul Mucofan, and Radu Vasiu. First, I want to present the scope or the motivation of this new dataset. The dataset tends to focus more on building recognition from the street view. This is actually a domain that nowadays is growing, and it's a domain where computer vision applications tend to come together with augmented reality applications for several scenarios or topics like culture or tourist applications. And in this paper, we like to present our new database that's composed of buildings from Timișoara, and is one that we consider is more fitting for image processing in this scenario. So from the beginning, we like to state that all the images from this dataset are actually from a street view perspective of the buildings and not from a satellite one. First, I would like to present some of the algorithms that could benefit from this kind of dataset. We have here two examples. One is a classical feature detector-based building detection, where the dataset offers the region of interest selection part where the algorithm can be tuned, and the other one is an example of a line feature detection matching for detecting buildings, where again the dataset could provide certain advantages. The data set is composed of 160 buildings, and for each building, the data set offers different perspectives of the same building and different lighting, or even conditions, weather conditions. This all is in the scope to offer a variety of testing certain algorithms or fine-tuning them. For example, this is one building that you can see that's presented in a data set, and you have different perspectives of looking at it, or different weather conditions, or even a night condition. So to get a bit into details, the data set offers 4 different things. We actually show only 3. We have the original images, all of them taken by mobile phones or in the street view perspective, with different resolution of the mobile phones, of course, to offer a bit of complexity to it. Then we have the edge ground truth or line ground truth, where we asked subjects, labelers, to label what they consider as an important detail or differences in the facade of the buildings, and completely, let's say, ignore the details around the building. This is because we intend with this data set to verify the line matching algorithms, or to train line matching algorithms. So we would like to see the efficiency on the building lines only. The third thing that the dataset offers is the semantic segmentation of the buildings, actually the whole environment. So algorithms can fine-tune the region of interest, or actually try to understand the environment. And the fourth that we cannot represent here, actually in the dataset, each building would have the GPS coordinates if you would like to evaluate a complex algorithm that takes in consideration the localization in real life. Okay, so technical details about the dataset. Like we said, in the moment of that paper was written, it was 160 images of the buildings. Now it's completely growing, so it's an let's call it, it's alive, and we'll continuously add new buildings as far as we have resources to do so. We with it we desire to have a common ground truth for evaluation of in the same framework of more complex algorithms. For example, like I showed in slide 1, ones that have a region of interest selections and then have a line matching part of it. We call these edges salient edges and semantic segmentation and GPS coordinate of the building. All of the images are actually in this resolution. This is a resolution that we consider as being somehow a trade-off between the processing power needed for this in the algorithms and the quality or resolution that modern mobile phones will produce. This is actually the resolution of most HD images. Now I want to go a bit in more detail and go to see the differences that we have first in the edge part or the line part, where we had to show them better. We provide an example between one popular data set is the BSDS 500, the Berkeley data set, where it's one of the commonest data sets for evaluation of edge detection. And we exemplified here one of the ground truth they have and the ground truth we offer for the same image. The differences is the fact that after multiple subjects labeled what they considered as relevant edge, we unify them in one single image. This will make the evaluation easier from our perspective. Of course, in the paper, you can find a more complex comparison between other edge detection datasets. As we can see here, we have the Berkeley dataset, the New York dataset, the multi-Q dataset, and structure edge dataset. As you can see, none of them are clearly focused on building detection or on salient edges, as we call them, on buildings. They offer information about the whole environment. And in this scope, we consider that our proposed data set is better for building localization or building detection. I would go a bit further because we're in the last part of this session. So the other comparison we did was with other semantic segmentation data sets that are available in literature. As you can see, we selected the original image from the data set. We have the original labeling that they offer or annotation, and then we made we transpose their labels to our labels, so we can clearly see the differences from what label spec do we offer in our dataset and the label spec that they offer. We have populars like A-Trims, Label Me Facade, ECP, ECC Graz, INRIA, CPM or VAR City. As you can see, all of them have somehow different focuses. For example, let's see in the VAR City where they focus themselves the annotation on the building per se, but completely ignore the details and not even label them. Or, for example, we wanted to avoid the focus in facade details that the CPM dataset offers. As you can see, we unified them together. For a better representation, we did a table representation. You can find more details in the papers, where we can see the analogy between the labels we offer and the labels the other dataset offer for it. And of course, the RGB code and the label number. This is an important aspect we consider because all of us that work in this domain know that usually you want to train or use multiple data sets for your algorithms, and then this would be an important input from the beginning for one researcher that wants to use multiple data sets to know how or what details are missing or are abstracted in each of the data sets. As you can see, our proposed data set, the TM building data set, focuses more on understanding the environment and not the details on the buildings as others do. Okay, so in the paper or in this presentation, you can find a review of existing boundaries or edge datasets, a review of existing semantic segmentation dataset, a dataset that will offer a better suited, from our opinion, dataset for building detection in urban scenarios. And of course, here are the links where you can find the dataset. The dataset is in this link, or you can find it in our end-to-end computer vision framework, where it's incorporated together with other computer vision algorithms. This is a list of references, and thank you for your attention. Hope I was brief enough.
Yes, thank you very much. Thank you very much. And I have one question. I find in your article you mentioned that you plan to expand in the near future the quantity of the data set images and ground truth images respecting the same principles that you exposed in the paper. So my question is, what result do you aim to achieve by expanding the image base, and will it improve something?
Yes, it will improve because if we talk only for example, camera-based image recognition algorithms, it's clear that the bigger the data set you have in the beginning can cover a bigger number of use cases. And when you actually train your algorithm and then deploy it to a real life example, and you pick up your mobile phone and you look around stuff, it easily gets into scenarios that you have not foreseen. And then the bigger the data set and the complex buildings you add to it will offer the algorithm the chance to actually foresee, or in this case us, to foresee weird situations or corner cases that we didn't see in the beginning.
So that's why you will include the images from different angels and something, yeah?
Yes, because if I go back here, you can see our main focus in this are mostly irregular shaped buildings. So you cannot apply a pattern to them.
Mm-hmm.
So then if actually the bigger aim in our research is to create an algorithm that can detect buildings in Timișoara, certain landmarks, historical landmarks. So then it's important to do that. So the algorithm can differ between buildings that look alike.
Okay, thank you very much. Do we have more questions? Okay, no questions. So thank you very much. And now we'll have lunch break till 2 p.m. And after that, we will back to the conference and we'll start the session 5, named Information Technology Application, special session on language technologies. And this session will be chaired by my colleague, Professor Jurgita Kapučiūtė-Dzikienė from Vytautas Magnus University, Kaunas, Lithuania. So thank you very much and hope to see you soon. Thank you.
Jo, dabar paspauskim.
Okay, good afternoon, everybody. And let me start the most interesting session of this conference. So it's my subjective opinion, but yeah, it's interesting session. And let me invite the first speaker, Lukas Stankevičius and Mantas Lukoševičius. They are going to present their interesting research work on generating abstractive summaries of Lithuanian news articles using a transformer model. But just before you start, I want to ask everybody to keep the time limits. So 15 minutes for your presentation and 10 minutes for questions. So the floor is yours, please.
Hello, everyone. So we shall start. Okay. Zoom. Share screen. So, generating abstract summaries of Lithuanian news articles using a transformer model. So I will talk about why we did this, how it is done, and what results we got. And in the end, I will show some examples to illustrate our results. So why we need to do it? If you look at the most popular library for transformers models, and transformers models are the state of the art currently for natural language processing, we would see that Lithuanian language is way behind, like in the bottom of the list. Of course, the most popular is English, so we decided to make some work and accelerate research for Lithuanian language. And we choose the topic of summarization. Currently, there are two types of summarization. One is extractive, when you extract the most important sentences or parts from the text. And our is abstractive, what we done. And this is when you generate word by word this summary, not extracting, but generating. So, and this generation became viable only recently because of these transformer models. So, in the right to see an article, and this summary usually is in the first paragraph. So this is how it looks. Now, how to do this? So we first have to have a big data set. When we have samples, we feed to tokenizer. Tokenizer prepares our text samples to the model, and our model does training and inference in the end. So like this, we feed text to the tokenizer, tokenizer encodes text, this text then goes to the model, and model predicts some encoded text. And then we compare encoded text with desired output text and a bit model. And this repeats many times, and we train, in this way we train our model. Now let's get the main parts in more detail. So the first is the big data set. In our case, it's that set of Lithuanian news articles. It's about 2 million of news articles. And it contains two parts, the body part and summary part. And the summary is usually the first paragraph, usually. So let's go to the next step. So it's a tokenizer. So in our case, tokenizer is something that first tokenizes text into some tokens, and then these tokens are encoded into the numbers which model can digest. So how to tokenize? To tokenize correctly, we trained on Lithuanian text, and in this example, in our case, we trained on 1 million samples of our text corpus, so that it would learn to tokenize Lithuanian text. So that's it with tokenizer, and let's move to the next part of our training process, is the model. So we use transformer model, and we use flavor of T5. This is a text-to-text model. Then you input text and it outputs text. So there are several options to choose the model. One is to use already available multilingual pre-trained transformer. and just fine-tune it, or pre-train from scratch for our task. So in our case, we tried both variants and found that using multilingual is very slow because it's for many languages, and almost the same performance we reach with training just from scratch. In our case, we train not from scratch, but from English version. So I will show more in the end in a graph. So now that we have everything covered, let's cover one more nuanced thing here. So during prediction, these things go out and we just input text, encode, model gives encode the text. Then we feed to the tokenizer and we get from numbers, we get text strings. Now, I already mentioned that model doesn't take whole text at once. It takes text by tokens, token at a time. So for example, if you have like this token, during each step, we get probabilities for the next token. In our vocabulary are 32,000 tokens, and we get probability for each. And now, like this, you know. So for this example, it will be if we show this like a probability. So in this example, the highest probability is for the second bar, you know. So we would take second bar. But there are better ways to choose than the highest probability. Actually, choosing the word with the highest probability is called greedy decoding. But there is over decoding. So there is greedy beam search decoding, where you choose like a defined number of best candidates and keep this number during selection of next words. Another is sampling. That means you select not the best, but with you randomly select from the top. And there are two methods selecting from the top. There is top K sampling from a top number of best, and the other is top P, and top P corresponds to the probability of a sum of probability which we want which we want to select from. So, and there is another thing I wanted to cover with stochastic sampling. It's the temperature. With temperature, you can rebalance these probabilities. So in the previous example, there was these bars. So if you choose a bit temperature, so one bars maybe go high bars, you can make high bars even higher, or you can make this distribution a bit flatter. So this is the generation about decoding. Now the next thing, you have to evaluate your summaries, and for evaluation we use reg n, and it compares number of n-grams between candidate and goal text. And currently I looked at nlpprogress.com for summarization of English language, and put here the highest numbers achieved for similar tasks in English. So now let's move to our results. So this is a big graph, but let's just stay with me and focus on how to digest it. So in the horizontal bottom axis, we have training steps, and we train model step by step, and these training steps are corresponding to epochs in this horizontal top axis. So as we see, our model like go to the 10 to the 1. That's mean 10. Actually, we train model for 22 epochs. That means we iterated through our data set 22 times. So now let's look how our model responded by training. So in the left vertical axis, we have rush in, and whereas two lines which go up and which go down. So around that 175,000 steps, it reached the peak, and this is the best results we get, and when our model starts to overfit. So at this peak, we get that actually there is two lines. One is greedy search and greedy beam search, and we see that greedy beam search is better. Actually, I showed these decoding methods. There is top key, top P, there is a temperature. We tried stochastic variants, various variants, but greedy beam search proved to be the best. So I don't even show it here, but I say it. The next lines is a learning rate. We use other factor that. So we like warm up learning rate to 10,000 steps, and then slowly decayed by square law. And then the next two lines is validation losses. So we tried training from random initialization and from English model. Well, actually, there is no sense training English model with Lithuanian language, but there are some tokens overlapping, so we thought that may be good. And actually, we see that loss is lower. So we kept training and trained it for another 500 hours. So that was our main model. So now let's, if you want, you can try our model. You have to go huggingface.com, Lukas Stankevičius, and this is in the below this link. You can go here. You can put your own text. That should be long text because we're doing summarization and press compute, and you can get your result. Actually, you have to wait a bit, but you should get results. So you can use it. Our model, you can fine tune your model. So feel free to do that. And remember to cite us. Now, how it looks like. So here is the summaries for extractive summary. This is existent summary, which was before our work, and our work for the same article. So we see that our generated text is coherent and it's shorter, and in this case, it's correct. So it looks like it does great. And while extractive summary has just too many sentences, which not maybe that summarizing. But if you go deeper into dynamics of how our model generates, we would see that it's not very stable, because during training, these generations for the same news article, and this changed quite a lot, and sometimes it becomes even fake summaries. It's misleading summaries. So in this example, only summary at 175,000 steps is correct. But this summary sounds, if you are a Lithuanian speaker, it sounds good. It's all grammatically correct, but it's just not the right. It has misleading text. So this is the main flow of which. And to conclude, I can say that we trained the first abstractive summarization model for Lithuanian language. We checked the summaries and found that it generates a great fiction summaries, but it's problematic to use in production because you cannot really very control how truthful or misleading summary is. So, and if you want to actually use it, you still have to rely on more substantial human intervention. So that's my presentation, and I'm waiting for questions.
Thank you very much. Do we have questions here? Okay, if not, then my question. What is the motivation behind selecting token, not photogenization, not the words, but character engrams? And what was the N for used in your experiments?
Why we tokenize not into words, but
yes.
in subwords?
Yes, correct.
Because the first I could say it's state of art currently, okay. And the second is that you can better express every word, because if you tokenize into words, like there will be like millions of words you can get. But for example, if you have a word like swimming, you can tokenize to swim and ing, and with these two tokens you would cover many tokens. So this is the reason behind this subword tokenization.
And what was the N selected for the character engrams? Do you have the fixed? Yes.
I already showed that we trained tokenizer for Lithuanian language, and we just left what it learned, that and that you actually together with a model you can download that tokenizer and just look for yourself how we tokenize Lithuanian language.
Okay, and the last question, unless somebody else wants to ask, but if not, you showed us the Rouge value, right, for the Lithuanian language. What we expect, how high we can go, what we want to achieve, what typically is the Rouge for example, English. How much we want to go?
Well, I showed in the Rouge slide that Rouge for the state of the art for English models is about, Rouge 2 is about 2022, okay, if I remember correctly. So this we would want to achieve, but I would have to mention that Rouge is not sufficient metric because it measures overlap between n-grams, while the same words can be expressed by another word. So you shouldn't entirely rely on that.
Okay, thank you. Do we have questions? If not, then I want to give you the certificate and thank you for your presentation. These are the different traditions, no shaking hands, but please.
Thank you.
Thank you very much. And we have another order, but we do not have the certificate. Okay, so now I want to invite another presenter, and we have it online. So we have Sergei Denisov and Frederick Simon Baumer.
Yes, hello.
Yes, nice to see you, nice to hear you. Can you show your slides?
Thank you, of course.
Please. Yes, we can see
my slides now.
Yes, we can see your slides, and you can start, please.
Okay, great, thanks. So, hello everyone, and welcome to my presentation. My name is Sergei Denisov, and I'm research assistant at the University of Applied Sciences in Bielefeld, Germany. And today I'm going to present the results of my master thesis, and the topic of our publication with Frederick Bäumer was how to improve the e-commerce search engines. And for this reason, we have evaluated the transformer-based named entity recognition on our own German product data sets. So what was our motivation for this work? So nowadays, we all very often use the search function on various platforms. And I think everyone knows when you can't find like the right products, so you basically have to adjust the search query or search over multiple sites for the desired item. And here, search engine optimization, it's not a new topic, it's a well-known problem in science and also in practice. And here you can see an example at the German Amazon marketplace. We have used the search query Kopfhörer, which means headphones, Bluetooth, 50 to 200 euros. And when you look at the results, so you can see we have here headphones, but actually the first two don't have the Bluetooth technology. And as for the price, they are not within this, the desired price range. So this is like one of the reasons why we try to optimize the search function. And like on Amazon, you have the different merchants, million of products, and usually all of them like try to optimize their product description and the product title. So also like the quality of the titles and the description differs a lot therefore. And okay, so what was our challenge actually? So as University of Applied Sciences, we usually work with practical partners from medium-sized companies, and one of our partners is Wöhler. It's a company which sells a lot of products, and like motivated by the Corona pandemic, they try to sell their products online and to expand their capability of their online store. And so, for example, they want like to optimize the search function and to filter or sort products by different attributes. And like on Amazon, as mentioned before, the merchants, they just want to rank their products as high as possible, while Wöhler wants like the customer to find the right products within the first couple of results. So yeah, and also if you see the nature of the data, so usually the product titles, for example, are much shorter than, for example, on Amazon. So yeah, how can artificial intelligence or natural language processing help to optimize search engines? So research trend goes currently like semantic search, but at this time we were like still improving the search engines with, for example, named entity recognition, and also this was like the requested approach by our partner. So I will briefly introduce named entity recognition. So it basically deals in the first step with the identification, and in the second step with the classification of the entities. And typical entities are like person, as you can see here, like John, location, Alaska, or like the organization Starbucks. So in the past, named entity recognition used to be performed rule-based, but currently the transformer-based models are like on the rise in the natural language processing. So they basically achieve state-of-the-art results in every natural language processing task. And so our approach was here like named entity recognition for the German e-commerce domain. And you can see here an example. So basically we had to define our own entities. For example, here like attribute for wireless, and then we have the headphones product and the Sennheiser brand, and Schwarz means black, the color. So we have also heard something about the transformer models in the previous presentation, but I want quickly to present the approach of these transformer models. So basically you have the unsupervised machine learning in the third part. In the first part, where the models usually gets trained on annotated data, like Wikipedia or a corpus of books. And yeah, they optimize the loss, and then they basically release the models, and then you can fine tune these models on your desired task. In our case, it's like the token classification task for the named entity recognition. So we use here our own data sets for fine-tuning basically these models. There gets an additional layer like edit, for example, for this classification, and then you compute like the loss or for example, the F-score for the named entity recognition. So how comes that these transformer models are that powerful? Basically, they get pre-trained on a lot of text on multiple GPUs over a long time period. And they have two objectives, like the masked language model. For example, you can see here as a sentence problems turning into banking crisis. And like the into gets masked out, and then the model tries to reconstruct this token. And this happens like for 15% of the tokens in a text. So the model understands the language better and better every time it gets trained. So the next sentence prediction, the model like gets two random sentences, and then it uses to predict if the second sentence follows the first, or if these two sentences are independent. So for example, like bird, it then understands the context of text even across multiple sentences. So one important question for us was what kind of data do we need, and what are the challenges? So basically we have acquired data from Amazon, as you can see here, slightly above 1.8 million documents, and from a German online shop, 16,000 documents. So we wanted to make a comparison between the Amazon data and the data of a German online store, where basically the content is professionally maintained by authors and writers. So we basically did some data pre-processing where we extracted the textual data from the HTML documents, and some data cleansing by removing unwanted characters and escaping HTML entities. We then removed like duplicates from the data, duplicate titles and descriptions. For Amazon, we also had to apply a language detection because we had a lot of different language in our data. And as the last step, we basically applied the cuisine similarity to select the most diverse product titles and descriptions. Because in the data, you have a lot of products which are like slightly different. For example, a solid steak disk, which only differs, for example, in the storage size. We wanted to filter out that. So yeah, here you can see our entities for our data set. So as an annotation tool, we have used Prodigy, and as a tagging scheme, we applied the below tagging. And basically, these are like typical entities for our data, for the e-commerce data. So for example, we have like brand, Canon, or the product. Here we have some products from the computer category. Then we have the model, the item number, and the quantity. You can see here as a challenge, basically this entities usually consist of many numbers and letters. So yeah, and for quantity, as you can see, you have 2 P's and 3 different notations for it. Then we have the color, like different colors. So we have not only like the standard colors here, but which are within a predefined range, but there are like also new color names which gets invented by the manufacturer all the time. Then we have the size. This can be like 250 gigabytes, or the physical size, for example, meters, or A4 for some paper. We also have then annotated several attributes which don't belong to the other entities, and the idea is so that you can derive new entities from that further in the future. Basically, for example, you have like the state of the product, which is like used or new, and could build a new entity which is called like state. So this are like our final data sets. So we basically have 3 data sets with 1,000 product titles and 3 data sets with product descriptions. And we have used the automotive and the computer category from Amazon. So basically, we wanted to have a diverse set of categories and also categories where we have some knowledge about, because for the annotation process, you basically want to have some knowledge about the category and don't use like Google all the time to find out what are the attributes or what do these entities mean. And we have like all categories from the online shop. So we have here 2 pictures. Basically, the left one is for the titles, and the right one is for the descriptions. And you can see the entity to this distribution. So at the x-axis, you basically see the name of the entity, and at the left axis, you see the tag count. So you can clearly see that you have much more entities at the titles data sets than at the description data sets. And the title data sets is like a good balance, except for like the quantity. In the description data sets, there are several entities which are completely underrepresented, like quantity, item number, brand, and color. But this completely makes sense, because usually in the titles, you have like all the entities and all the information, while in the description, there's like a lot of unnecessary data for us, which doesn't have any entities. So I will quickly introduce which frameworks we have used. We used the simple transformers library and the weights and biases library for the hyperparameter optimization. Basically, at the right, you can see the different hyperparameters which we have tried out and which were like the best. And here you can see a screenshot from this weights and biases library. This was a very nice tool to help us with this optimization. So basically, you train the models with the desired hyperparameters, and then, for example, you select the largest F-score, and you can then see the parameters, for example, in this case, like the train batch size of 8, number of epochs 4, and the learning rate of 0.00005. And this leads like to an F-score of 0.929. And so here like are our results for the different models as mean for all data sets. So we have basically at the x-axis model names, and at the left we have the scores for the precision, recall, and the F-score. The first model here is like the conditional random field model, which we just used as a quick implementation and a baseline model. And then we can see the multi-language, the German BERT, and the Roberta model. So basically, all the 3 models achieve like nearly the same results. German BERT being slightly better than the others too. And the F-score is around 0.83. And the best model was like the XML Roberta model, which is also a multi-language model trained on 104 language from Wikipedia. And this model outperforms the other models by a lot. It achieves like F-score of 0.86. So basically at the last slide, you have seen the results for all the data sets, but here you can, this was like the average column at the right. And here you can see the detailed results for all models and every data set like. So there's online shop titles, Amazon titles, computer titles, and the descriptions for all the data. And what you can see here is that like titles usually achieve a better performance than the descriptions. And like the data from online shop basically outperforms the Amazon data like clearly. As you can see for the titles from the online shop, you achieve an excellent performance of 0.95. And here, as for Amazon, the automotive categories slightly outperforms the computer category. Yeah, and these are our conclusions. So online marketplaces, they have different quality standards for publishing their data, basically. We have seen this at the annotation process, where we discovered a lot of errors at the Amazon data. Yeah, and in order to optimize or to get the best named entity recognition results, you have to have an even distribution of the entities, so they are not too underrepresented. Yeah, furthermore, the transformer-based models achieve excellent named entity recognition performance for the German language. And with a small amount of data, as you have seen, we had like 1,000 examples, but with like 500 examples, the results were only slightly worse. And yeah, the XML Roberta is the best model for the German e-commerce data set at that time, that was at that time. So here are some references, and thank you for your attention.
Thank you very much. So do we have questions? Okay, then I will give you one. So why do you think that monolingual German model was actually little bit worse compared to multilingual XML Roberta model? Isn't it because some named entities have the origins of the English language, like the specific terminology that you were searching for? Isn't it the case? Why do you think multilingual model that is specifically tuned for the German language actually performed worse compared to that?
Yeah, I think that you are right there, that there are a lot of vocabulary also in the English language, like the brand names, for example, they are like all the same. And also I think this XML Roberta model, it's a lot newer and it performs in general better on the named entity recognition. So that's a better technique.
Okay, so other questions? I also do not have more questions, so thank you very much for participating, and thank you.
Yeah, thank you, and I hope to see you next time in real life.
Yes, of course.
Bye-bye.
Bye. So we are inviting Mikas Binkis, Ramūnas Kubiliūnas, Rima Sturienė, Tatjana Dulinskienė, Tomas Blažauskas, Vitalija Jakštienė. And they are going to present their work, rule-based chatbot integration into software engineering course. Please.
So hello. So we will present it together who we are filing. I'm not sure. What do you think when you see the word chatbot? Probably about some kind of artificial intelligence. So our presentation, it's not about it. We're actually afraid of artificial intelligence. So we will talk about better learning experience using this stuff.
Yes. So we would like to start speaking about the chatbots themselves. So actually, when we are talking about chatbots, we are thinking about virtual assistants. So basically, it's a software that can perform some type of commands based by the answers that are given by the user. So basically, we can converse with that type of software. And when we are talking about chatbots, we are thinking about online virtual assistants, since usually chatbots require internet in order to work. So actually, this piece of software has been known well since the last century, and actually it has quite the potential in the fields where common user interfaces are not still available. So for example, in virtual reality, it's quite hard to interact with an environment. So that's why chatbots may provide some additional advantages over there. And actually, when we are talking about chatbots, you may have seen them in a lot of spheres. So for example, social networks, e-shops. So actually, they are used quite extensively right now. So this is an example.
Yeah. So here you see the Grace. So Grace is our actor, let us say, virtual assistant created by Lucas. But it's not the only one actor we created for a chatbot. So we have something like mechanical eyes, DNRs, heads, and other stuff. So for virtual reality, we use anything that flies. So this is one of the purpose we are trying these chatbots to include into education.
Yeah, and when we are speaking about chatbots, there is no such official categorization of chatbots, but they can be categorized by the development techniques. So the first one is rule-based conversation technique. So basically, this approach implies that we are using some kind of rules or scenarios which the chatbot uses. And actually, this type of chatbot cannot answer that many questions if, for example, your query is quite complex. So it's quite easy to develop, but it's quite hard to use. The second approach would be the deep learning approach, and this method actually implies that we are using machine learning for chatbot development. And this type of chatbot is is quite smart. It can answer a lot of questions which are provided in a lot of various ways. But the development of such chatbot may take quite a lot of time, and it needs a lot of data and training in order to do that. The third method of chatbot development would be ensemble methods. So basically, it means that we are employing quite a lot of techniques. So basically, those approaches that I have presented to you earlier, and these methods actually provide even better results. But still, they are quite hard to develop. The fourth one would be domain-specific chatbot approach. So it means that the chatbot is limited to answering the queries in some certain field. So, for example, like healthcare, education, or e-commerce. And this type of chatbot cannot answer that many questions outside its field, but the knowledge that it provides is quite extensive. And the fifth one would be the usage of a chatbot builder. So it means that we are creating chatbots using a software specialized for people that are not programmers, and there are quite a lot of software created for that. And just by creating the rules, creating the scenarios, you can basically build yourself a chatbot. So actually, we analyzed quite a lot of work regarding to the chatbot. So we found that the students are usually more likely to use conversational assistants or those chatbots in larger classes because, for example, if a teacher is not available, so the chatbot is quite useful for them. So we also found that chatbots can help teachers to find early knowledge deficiencies in students. And it can help for students to catch up without being judged or mocked. So actually, in these uncertain times with COVID-19, so it's quite easy to see how chatbots can be useful in real life situations, such real life situations in education. And the third conclusion that we found analyzing the work, that the students actually fall back quite fast to traditional informational sources if the chatbot is not working properly. So actually the whole usefulness of a chatbot is, and practical application is whether this chatbot is working properly, if their answers are correct, and the success rate of the answers is quite high. So we have created our chatbot. So I will.
Okay, so of course we took the easiest approach. Why would take the hardest one? So it's a rule-based approach. We use speech recognition, but we do not recognize it ourselves. We use the browser engine, so it doesn't need to connect anywhere. And in order to understand the answers, because these recognition engines cannot provide us correctly what the person says, probably you wouldn't understand every of my word correctly. So we use the Levenstein distance in order to find the nearest answer. So this is the example. Okay, so for example, the engine will return my concepts when I was trying to answer main concepts. And in order to find which one is the nearest one, we calculate Levenstein distance. So here from this we see that the main concepts is the nearest candidate for my concepts. So in such a way, we select our answers. And we provide answers just by talking. Here you can see the context of the chatbot. So the learner watches video, and the chatbot initiates conversations and also assesses the learner, and teacher within the LMS can find those answers and use it. So for experiments, we implemented the chatbot. We will see it shortly. And that chatbot took a video of 900 seconds. It is split into 4 parts, and after each part, the chatbot asks student one or another question. So let us see. So the chatbot is presented, prepared as the SCORM package. It means that you can just take that zip and upload it to any learning management system you like. Of course, that learning management system should support the SCORM standard. And after uploading it, you can basically start, can use it. Okay, so I will probably move forward.
Let's save
But
that resource. And
probably not, because it starts right now. So in the Moodle, we'll launch our lecture and chatbot
Would you like me to assist you?
Sure.
What would you like to play?
Well, everything.
So now the assistant is performing what we
In this video, I'll talk about software engineering
she
and
was asked
software
for,
project management in general.
and it supervises the video until some moment for the interruption.
Software engineering methods. So
Let us stop here. I want to ask you, Why there are still so many failed projects nowadays?
I guess because of increasing system complexity.
Yes. The increasing system complexity is the major challenge.
As you may notice,
Let us proceed.
I didn't answer exactly. I added
Definition.
several few words, but it's still recognized my answer because we use that Levenstein distance approach.
And
Several more examples
software is
of a
modified
chatbot.
to reflect changing customer and market requirements.
Let us take a pause. I want to ask you, what software engineering discipline is concerned about?
About all aspects of software development.
Yes. Software engineering discipline is concerned about all aspects of software development. Okay. Let us proceed.
And so in such a way, we proceed through all of the 4 parts. And in the end, the chatbot assesses us and writes
That was interesting.
my score into Moodle
Which challenge do you
LMS.
fear most?
I fear business and social change.
Thank you. That is a really important challenge. Okay. Let us proceed.
So we will not proceed. We proceed other ways.
Yes. So actually, we tried to find whether our chatbot is good or not. So we had an experiment with second-year undergraduate students who took software engineering course, and the usability of this chatbot was evaluated using a system usability scale. So this questionnaire has been created according to the original SUS questionnaire. It was a little bit shortened, but the best thing about this questionnaire is that it allows us to evaluate the software, even if our scale of the experiment is quite small. So the results show that our chatbot is not very good. A lot of students thought that something feels off. It was not providing the accurate answers they asked, but still the usability was somewhat average, and the learnability aspect was evaluated quite high. So it means that students probably like the new method of learning, but the whole quality of this chatbot basically needs more development.
Okay, so we created that chatbot to see how it looks like in the real setting for real students to try. We used the system usability scales, and it showed that our system was a complete fail. But well, it was because of a user experience issues. For example, some students didn't know that they can interact with audio and just speak, and if their microphone was on, so they ran into some unpredictable experiences. But these are easy things to correct, and the overall attitude was quite positive. And we will try to improve the solution, but probably not for such web browser applications, but for virtual reality experiences where we actually really need the assistance, because here we are alone and we need a friend to make our learning successful.
Thank you very much.
Thank you very much. Do you have questions? Yes, please.
I would like to ask, are these options provided, answer options provided by chatbot, are they hard-coded, or you can, for example, lecturer can configure the answers and he can add additional answers?
Okay, thank you for the question. So it's both cases actually. In the chatbot you have seen, it is hard-coded just for the experiment. And in this example, where we see this chatbot it uses exclusively data structure XML to describe all the behavior, where it should stop, what it should ask, what answer should provide, and how to react to the answer. So it's not really far away from the tools for the teachers to create their own chatbots.
So in general, you are on the way to create kind of environment for lecturers, for teachers, to create his own scenario for particular lecture. Yeah?
Yes, so teacher would have to upload his video or her video to YouTube.
Yeah.
Then just pinpoint with top points, questions, answers, and it should create the zip file to upload into any platform.
Okay,
thank you. And we have one more question in the chat. So.
So the e-learning public always wants to know what tool did you use to develop the SCORM package?
Oh, well, it was our own intelligence. So basically, we just investigated the structure of a SCORM and created everything ourselves. No tools were used.
Okay, and one more question for me. Don't you think it's a little bit unfair to create the system for the English language, but not for the Lithuanian?
That's a very good question. You know, in our project, we had partners from Bulgaria, Greek, Portugal, English, yeah. So we made such a several videos for all the languages. But we didn't find the good synthesizer for Lithuanian language. There is not a one which can produce such a quality speech.
Well, our next presentation will be related with the speech synthesizer for the Lithuanian language. Maybe this is the space for collaboration. Okay, thank you very much. Wait a minute, I just want to give you the certificate. Thank you very much.
Thank you.
And thank you very much. So we have one more presentation, and we have Arnas Radzevičius, ICIST Raudys, and Pijus Kasparaitis, and the presentation will be speech synthesis using stressed sample labels for languages with higher degree of phonemic orthography. Please.
Okay, 1 second. Yeah, I need to stop sharing that. Okay, so hello, I'm Arnas Radzevičius, and I will present my paper titled, our paper titled Speech Synthesis using stressed sample labels for languages with higher degree of phonemic orthography. So first I will do an introduction and background on the domain. So I will do an introduction first on speech synthesis. It is artificially generated human speech. Also, the systems that synthesize speech are called text-to-speech synthesis. And the goal here is to, given a text line, a sequence of characters to output a speech waveform. And biggest challenge here is naturalness and quality of the speech. So naturalness is how much does the pronunciation and intonation and other features represent of the synthesized speech represents the real human speech, and the quality is mostly the quality of audio itself, because it's because audio contains a lot of samples, and a lot of times it's hard to
generate so many samples for computer systems. It's computationally expensive. And traditional text-to-speech systems were concatenative and parametric synthesis systems. For concatenative systems, basically what they did is they pieced together synthesized speech using some algorithm to pick out the appropriate short speech segments from a large speech corpus. And parametric synthesis introduced statistical methods in generating speech, but well, it's suffered from audio quality and naturalness issues. By introducing neural networks to the field, the performance of the text-to-speech systems were improved quite significantly. And not only the performance was improved, but also the developers who develop the text-to-speech systems didn't need to spend so much time in manual engineering. That is, they do not need to spend a lot of time developing algorithms and so on. They can just focus more on data and train the neural network from that point. Of course, given if the architecture of neural network is already developed. So what data is needed to train neural networks? And I'm having in mind now a supervised learning task. So that means that we have labels for our text, and yeah, we need to make a speech corpus, which is a data set containing text and speech waveforms, speech audio waveform pairs. And on the slides, you can see an example of such a pair. On one side, we have a text and another a waveform that corresponds to the speech. Okay, and since it's really hard for neural networks to learn generating text, to learn generating speech directly from text, it is a common practice to split up the architecture so that it's easier for the neural network to learn the features. And the most common architecture is to train an acoustic model, which learns to convert the text sequence to spectrogram, more specifically MEL spectrogram, which just represents the speech features more explicitly, at least more understandably to the computer. And another step would be to get to give this generated MEL spectrogram to a vocoder model, which then learns the features of the spectrograms and generates the final audio waveform. And yeah, 1 second. Yeah, so since it's a problem for a neural network to learn from raw data, to learn features from raw text and raw audio waveform, the data is pre-processed. So first, both for acoustic model and vocoder, the audio waveforms are converted to MEL spectrograms. So we would have the labels as not as audio waveforms, but as spectrograms. And also the text is pre-processed, often pre-processed, so that not the raw text is inputted to the model, but that the phonemes would be inputted to the model. And that's a really big simplification for the model, because I'll just comment that the phonemes are the smallest units of sound in a word, and the grapheme just represent it's just a textual representation of that sound. And it's way easier for neural network to learn to generate speech directly from phonemes, because the phonemes actually encode all the information, whether the sound is long or short, and so on. And it's especially important in languages like English, which are not, which has a low phonemic orthography, on which I will comment later. And yeah, in this way, the neural network just does not need to worry about additional context. So yeah, most text-to-speech research was done on high-resource languages like English or Chinese. And since for these languages, pronunciation dictionaries are usually open source, there's no problem for them. And I didn't mention that these high-resource languages just usually uses pronunciation dictionaries to convert the raw text to the phonemes. But pronunciation dictionaries are not publicly open for publicly available for lower resource languages like, for example, Lithuanian, and they are also really hard to compile. So a different approach must be used to overcome this speech synthesis pronunciation problem, because the problem here we are facing is that without the phonemes, it's hard for a neural network to learn to pronounce words correctly. Okay, and about phonemic orthography, that is basically how much do the written symbols correspond to spoken sounds. So if we have an alphabet, the letters in the language, how much do they represent the real spoken sounds, yes. And for example, English has a low phonemic orthography because, for example, if we have grapheme th, it can be pronounced like the, and the word this, it can also be pronounced like the, and the word thin, and it can be pronounced more separately in the word goatherd, for example. And a lot of research was done in text-to-speech systems in English. So pronunciation dictionaries, as I mentioned, are compiled a long time ago, and they're open source. You can get them for free. So a lot of research was done using these pronunciation dictionaries, but other languages does not have this commodity. And we have in our paper we use an example. We train text-to-speech systems, text-to-speach system in Lithuanian language, and this language is slightly defective. So there are other languages that has a high phonemic orthography, which means that most of the letters or all of them just corresponds to the spoken sounds, and those languages are Finnish or Georgian. But Lithuanian language is slightly defective, and that's mostly because not all of the vowels are really distinguished, and letters like I, E, and A can have longer or shorter sounds. But we come to another concept here, which are pitch accents, and in Lithuanian language, we can put pitch accents or stress marks on a letter, and by this way we can give the information which vowel should be said longer or shorter. So yeah, in Lithuanian language, usually graphemes are spoken pretty much the same as they're written, but again, because the vowels are not fully distinguished, the same words can be pronounced differently depending on the context. So we have an example here where the word pastato is pronounced differently in the sentences eikite iki pastato galo and atsargiai pastato ant stalo. So the stress is just on the different vowel, and the word is pronounced differently. So for neural networks, it's hard to catch this nuance. Okay, so again, pitch accents can provide information on which vowels should be longer or shorter. All right, so let's move on to our paper's experimental setup. We used popular open source speech synthesis neural network architectures. So for acoustic model, we used Tacotron architecture, which learns to convert text to spectrograms. And we used WaveGlow as a vocoder. And we actually use the same hyperparameters as in the original Tacotron paper, because we didn't observe a lot of change if we modify them. Okay, so for the test, we have composed a Lithuanian speech corpus that contains 91 hours of labeled speech audio. So speech and speech audio and text pairs. And all of this audio is from one speaker. Only one speaker is present in this data set. And originally the text labels were not stressed, but in collaboration with Pieskas Praitis, the labels were stressed using a semi-automatic method by running all the labels through an algorithm and then having a human expert correct the stressing mistakes. Well, it has other details, but I will not get into that. Okay, and so for the results, so the vocoder was trained for 84,000 iterations. Yeah, so we don't analyze the vocoder part here, but we also trained 2 acoustic models. One of them used non-stressed text labels, and another one used stressed text labels. We trained both of them for 24,000 iterations, and a mean opinion score survey was used to evaluate the models. Okay, so more on the mean opinion scores. It's basically a subjective evaluation score where participants are given a survey to complete, and they need to rate the speech, the synthesized speech or the speech samples in a scale from 1 to 5. So 5 speech sources were evaluated. 4 of them were the combinations of a pre-trained and fine-tuned vocoder. So that's for the quality. So that's just to see how much the quality of the synthesized speech differs. And another combination was that the acoustic model was trained on stressed and non-stressed text labels. So 75 samples were given to the participants, and each of them needed to rate these 75 samples on a scale from 1 to 5. And final results were average for each speech source. So here we can see the results of this mean opinion score survey. I didn't mention that we also included in the survey the ground truth labels, which just means that those were the real human speaker samples, and you can see that at the bottom of the with the highest mean opinion score. But what we can see from this table that the model that used a fine-tuned vocoder and also used a stressed text labels achieve a significant improvement over other models which used, for example, non-stressed labels or not non-fine-tuned vocoder. So this way we can see that the stressing really improves the performance of speech synthesizers. And here I provide a few samples of synthesized speech. So first non-stressed, the speech that was generated on non-stressed text. And I just want to make a note that you will hear two different voices, and that's because yeah, after the paper we trained our model on the second on a second data set. We do not train, but we fine-tuned it on a smaller data set, but just with a different voice. And it also had better audio quality. So maybe you can also observe the difference there.
Išeikite į lauką, pasukite į kairę ir eikite tiesiai iki pastato galo.
You can see that the pastato is pronounced wrong because the neural network does not distinguish the stress.
Atsargiai pastatė jį ant stalo.
Yeah, and this voice was used in the original mean opinion score survey, and the final one is.
Sveiki atvykę į tarptautinę informacinių ir programinės įrangos technologijų konferenciją Santakos Slinyje.
So yeah, it's not really intelligible, as you can hear, but when we introduced stressing to the labels, you can hear a difference.
Išeikite į lauką, pasukite į kairę ir eikite tiesiai iki pastato galo. Sveiki atvykę į tarptautinę informacinių ir programinės įrangos technologijų konferenciją Santakos Slinyje.
Atsargiai pastatė jį ant stalo.
So yeah, it's not perfect, but additional research may be needed to improve the performance, but at least we can observe that the right vowels are accented in the text. So for future work, we plan to develop an automatic stressing model because for this data, because now we need to put the stress marks on the text. The user needs to put the stress marks on the text and as an input for the model, and that's pretty tedious. So we would like to use an automatic stressing model, and also for the Lithuanian language case, since we only need to distinguish short sounding vowels from the long, we can just use tilde and acute stresses. So maybe that would simplify the learning task for the neural network. And we would, there can also be possibility to try to compile a pronunciation dictionary and train a model using the phonemes, but that may be really a resource that may require a lot of resources. And also we can try, we would need to maybe clean the speech corpus because not every out of speech utterance is labeled correctly. And for the conclusions, in the paper we propose the use of stress text labels to train a speech synthesis neural network, and the main problem here is speech pronunciation. From the results, we can see that stress text labels improve the performance, more specifically naturalness of text-to-speech neural networks for higher phonemic orthography languages like Lithuanian. And yeah, no other approaches may be used for low-resource languages to achieve good results. And as a final remark, I just want to say that although the approach is a small modification to the usual workflow, but this study may be useful for someone whose aim is to train a text-to-speech neural network for a low-resource language. For a low-resource language. Thank you.
Questions? No. Okay, then I have a question. You know, subjective opinion is always subjective opinion, and you will probably never get 5, you know, with some people.
Yes.
So how do you think how much there is the correlation between the accentuation and between those values? Because there are other things as well that are also important when evaluating speech synthesis, like how good the numbers, you know, are pronounced, how their endings are adjusted, how abbreviations are pronounced, and other things. So how do you think, what is the tolerance level here for accentuation? Because Lithuanian language is probably the most difficult in the world.
Yeah,
this point of view?
I'm not sure about specifically accentuation because, well, the participants of the survey are just asked to rate the naturalness subjectively, they are provided with a speech utterance, a spoken sentence, and they just are asked to rate from 1 to 5. They are not provided with like some guidance on whether to rate the pronunciation or intonation. For example, it could be a really greatly pronounced sentence, but maybe the audio was poor, and some user would just rate this as a 1 just because he didn't like the audio. So I guess from a statistical perspective, if you have enough participants of the survey, you can just get the average of all the scores.
Okay, and a little bit about those synthesized sentences. How difficult they were? Did you have, I don't know, something like abbreviations, numbers there, or not? How difficult?
Actually, for abbreviations, usually this is for current systems. This is just a step and this is just a text pre-processing step.
It was not encountered in
no, we didn't include it because it does not research the neural network itself. Because, for example, in English, you just have like a dictionary which maps each abbreviation, like Mr. or Doctor and so on, to its full words. So we didn't do that, but maybe, yeah, if you want to develop just a productional system, we would do that, of course.
Okay, so, thank you. No questions? If we do not have questions, then I want to thank the speaker and give you the certificate, please, and also to your colleague.
Thank you very much.
And so, it is nice that this year we had 75% of participants here in Kaunas. So let's hope that the next year foreigners can also come and we could all be together and share our ideas. So thank you very much and hope to see you all next year and more of you, of course. Thank you.
Thank you, Professor Kitla Kuchut-Dzikienė, for excellent sharing. Thank you very much. So it's certificate and small.
I can take both. Thank you very much.
Cool.
Samutinat. Dear participants of our international conference, welcome to our session. And today, really, it's a big honor for me to open this session and to see some participants, not only virtually, but in our room. And of course, welcome to Kaunas University of Technology, our friends from Ukraine, Romania, Bulgaria, and other countries. I'm not sure how many participants will participate virtually, but I see our presenters. And now we have 90 minutes and we have 6 presentations. Each of you have about 12-15 minutes, and on the end of your presentation, really, you will have chance to answer 3-2 questions. And now I would like to invite our first speaker from Ukraine, Anna. As I know, Anna made a video as additional resources if internet connection will be not so good. But Anna, welcome.
Yes, I'm online. Hello to everyone.
Yeah, could you continue your presentation and share your file? Maybe everything will be okay. Okay,
I hope so. Let me know that everything is okay.
Everything is okay, you can continue.
Oh, okay. One more hello to everyone. My name is Anna Marchenko. Today I present Sumy State University, the Faculty of Electronics and Information Technologies. I'm Deputy Dean for Learning Techniques at our faculty and also the Associate Professor at Information Technologies Department. Today I want to present my co-authors, whom you can see right now on the slide. We're very glad to be a part of this conference, and I want to thank a lot to organize a committee for our technical and emotional support. During my speech, I'll present the main result of pedagogical experiment for blended learning implementation in the educational process of Information Technologies Department. Sumy State University started a blended learning experiment in 2016 to find the optimal model of the educational process. But nowadays it becomes much more actual. Digital technologies are becoming increasingly important today. Mastering the digital technologies competencies becomes an essential factor in the success of social, economic, business, and also educational activities. We also need to remember about a significant part of the self-activities of students of higher educational institutions. Such distribution is typical for European and also Ukrainian higher educational institutions of both private and public types. Therefore, the emphasis should be on involving students exactly in active independent work, in our opinion. Now it has led to the description of the classical approach to the full-time educational process and to the forced transition of educational institutions to distance learning. Despite the wide range of internet technologies, most higher educational institutions are expressing some difficulties in organizing a new format of studying. Blended learning, which combines face-to-face classroom work activities with interactive online elements using digital technologies, has replaced the classic approach of organizing the educational process. Its main feature is to use information and communication technologies to identify new didactic opportunities. And application of the blended learning principles in pedagogical support, practice support. The following task you can see right now on the screen. It was a task of our experiment. According to the strategic approach to the development of digital skills and competences provided by the European Union, today it is impossible to support the development of human personality without the digital transformation of education. The Joint Research Center has developed 2 basic frameworks to support the coherent conceptualization and development of the digital skills and competences among European Union member states. Digital online learning DOL seems to be a gradual transformation in the introduction and individualization of pedagogy for learners, including people with disabilities, and also in providing a solution for the lifelong learning opportunities also. The idea is to combine the concept of technologies, digital technologies and educational technologies. And the most balanced combination you see right here. of this concept is the essence of blended learning technologies. Digital educational technologies are defined as being developed for or used for educational and teaching activities in formal and also informal education context. By examining the different ways of designing blended learning courses, the distinct approaches you can see on the left part, right? These were identified as you can see. Low impact blend is to adding extra activities to existing course. Medium impact blend is to replacing some activities, and high level impact is to building the blended course from scratch, the new model of teaching. And classifying these approaches as low, medium, and high impact blends has been done according to the potential changes to the existing teaching program and students' learning experience. Our tested model was at the medium high blended approach. Among whole blended learning models, the flipped classroom model is one of the simplest according to the organizational and teaching and technical aspects. In addition to the traditional approach to this implementation, when students study the proposed theoretical materials with consistent consolidation of skills by performing some practical task, individual project, and summarizing the knowledge gained, there are a number of additional options shown on the slide. Our model used a debate-oriented approach with mastering the material of massive open online courses proposed by a lecture on the topic of the problem with future discussion face-to-face in the classroom activities. Also, active learning technologies. The choice of active learning methods used to organize students' work is determined by the specific of the particular discipline or specialty, and usually is not wild enough. But according to obtaining practical skills, the imitation learning methods which are offered to use during classroom meetings activities are considered in our experiment. The next, project approach. The presence of an organization stage for the project preparation, also the selection of leaders from the project participants, the distribution of roles, and the development of a separate project task by each of the participant groups should be considered as characteristics of the project form of training. The experience of choosing the project format training is defined by the purpose of getting as close as possible to the real activity condition of the future experts in computer science. Among the existing types, group project and telecommunication projects were selected to implement in our tested model. And let's move exactly to our model. The proposed unified blended learning model combines a classical classroom approach and digital education approaches for providing flexibility and continuous mastering, both professional and digital competences using effective training. The model is presented on the slide in two parts. Independent work, safe placed activity to the left, containing the following types of learning objects. Learning the materials of massive open online courses and path and test. Then performing the project working groups. Analysis of discussing issues by forming a shared common document with the results of the sources review according to the declared problem case in the learning environment. To organize this type of work, it's possible to use, for example, the Google Classroom resource. As for Sumy State University, we have developed our own digital learning platform for this. Later, the material from this shared document is discussed in the classroom. Performing this task provides the information such important competences as the ability to analyze the available information in order to seek the solution to given task. Also ability to make informed decision within changeable conditions of modern business. Development of mind maps also is learning activity to the top based on the material of massive open online courses using some cloud applications taken in order to learn the material more effectively. The classroom activity work with the lecture covers the following traditional activities shown in the right slide. also is purple. Listening to classical lectures, of course, from the main based theoretical blocks of discipline. Implementation, practical or lab tasks, also discussion of problematic issues, and then analysis of mind map developed the group based on the mass of open online courses during lecture seminars. The final control unit is organized in the form of testing. Of course, the other set the goal to form an universal complex model of blended learning that would allow students to master both professional and digital competences in the process of continuous digital learning. Moreover, an universal model includes the most from our point of view, effective teaching approaches and technologies, and is adaptable for different specialities. This diagram schematically shows the recommended distribution of points in relative values, based on 100% of the points for the full scope of the course task. From the chart, it's clear that the majority of points, the green part, are assigned to the evaluation of students' independent and collective work. However, such ratio of points is just recommended and may be modified by the lecturer in accordance with the particularities and features of the discipline or within the educational program. Also, there is a possible scenario when among whole learning objects are those that are compulsory to perform in order to get the access to final test, and optional ones that can be performed to get high points at the end of the course. However, it should be kept in mind that the students can get the required number of points to complete their course successfully, only if he or she performs all required tasks. The generalized algorithm for the active method implementation into academic disciplines are shown right now on the slide. The first two stages concerns the analysis of existing models of role distribution in project teams and the selection of the best one to form a successful balanced team. When the role characteristics of the project team members are defined, the Bellman models were used. After the formation of project groups and selection the technical and software tools of the project management methods, students start the direct implementation of the group projects, the lowest part of the slide. The chosen method of flexible design allows, in the short term of the discipline study, to carry out several iterations of designing working teams in accordance with world standards and approaches. It's important to correlate the availability qualities in the team for effective teamwork. Evaluation of the balance of the role structure of the project team is determined by the final assessment of the role manifestation in the group. It's formed as the highest one among the assessments of the ability of each team member to fulfill this role. And then integral indicators allow to determine the effectiveness of a team through the balances different role within one group. According to the experiment results, we can confirm that the project approach implementation is appropriate through the flipped classroom. Each of above mentioned organizational stage to the left, green blocks, was implemented by the steps chain shown on the slide. During the independent group work, students studied the MOOC materials and analyzed the internet resources to find an array of possible solutions to the algorithm tasks. As a result of the comparative analysis of the existing solutions for compliant in a common document, as I already said, during the classes, the students discussed their findings to make the best possible choice and the final decision regarding the optimal solution. Such redistribution of the learning activity types between self-paced learning and classroom study aligns with Bloom's modified taxonomy. The implementation phase to the right in the classroom involved putting the more independent self-paced learning results into step-by-step action when the project team did the task according to the Scrum Agile methodology. Those students independently acquired the skills of agile project design under the supervision of the instructor, lecturer, and customer in the one person, who actively participated in the specification phase of the main functions of the product, especially in the project presentation result. Our divided on two blocks shown on the slide. Moving to the conclusion, I can say that the key feature of the proposed model is that it combines the classic approach in the classroom and digital educational approaches. It's effective in supporting and facilitating students' independent work, their responsibility for common work with the material. The model is easily adapted to the teaching of different disciplines of both professional and general orientation, taking into account their specific needs and characteristics. It's also achieved due to the structural complexity of the unified learning model and to the distribution of educational goal. The combination of different type of learning activities to practice the curriculum components in one model creates a comfortable learning environment for mastering the material. The combination of classical and interactive active learning methods personalize education. Applying a project approach to perform a collective task supports the development of digital and communication skills, which are essential for the success of the individual and the society, as well as an economy in general. Formation of the project team preparing the adapted specialists who are capable to start solving professional tasks in the shortest possible time after the graduation in the university. The search for the optimal combination of learning technologies can take several iterations with a continuous process of implementing and evaluating new components. It's time-cost process. Consistent deep analysis of the discipline purpose and process of tasks for identifying all the learning components of the course, which is better to represent online, is required, as well as detailed analysis of available educational classical advanced technologies for selecting those that the best meet students' needs and should be made in face-to-face activities. Advance to the next level, for our opinion of the present blended learning model usage is based on deepening the mechanisms for implementing digital educational technologies more deeply level and searching for new teaching methods that should our students be more interested in studying activity, Thank you for attention. If you have any question, I'm open for you. If such question will be, begin much later, you can use contact information. You can see on the slide.
Thank you, Anna. I think you can stop sharing because usually when we have some time, I'm asking, maybe do you have some questions to Anna? But Anna, you spend 7 minutes. And if some of you want to ask, you can send some questions by chat, of course, in YouTube again, because we are broadcasting this presentation on YouTube. And later on, maybe on the end of our session, if we will have some questions, you can answer. Thank you, Anna. Could you stop your sharing?
Okay, but let me find.
Okay, you can move your mouse and you will see some red.
I guess. Oh.
Okay, now Anna want to show all data about Anna, email, telephone number. Okay.
I guess I leave
please,
and then
please move your mouse and you will see some red usually.
Yeah. No. Oh.
Of course, I can do myself.
Oh, I find it.
Thank you, Anna. Now we are going to our presentation. Presenters sitting in this room in our one of the biggest video conferencing room in Lithuania and one of the more modern, Santaka Valley. And I would like to invite Daina Gudonienė, and she will do 2 presentations. Daina, floor is yours.
Thank you and good afternoon. As it was mentioned, I would like to make a presentation as a team working in NODE-NT project, which developed the paper on engineering solution for a correlation between competences framework and learning units in an educational platform. So the idea of this research was based on assessment tool, which is usually very important in all open online courses. And in the paper, we had, of course, introduction, literature review, also focused on different assessment methods and discussion. So the aim is, no, sorry.
Also, my mistake.
Yeah, sorry, I will show. Yeah. So the aim of the research is big. The aim of the research is to explore the factors that affect the effective open online courses design, to find the competences necessary for the academic staff and the designers of the open education courses, and to develop an engineering solution to implement open learning in an educational platform. Of course, usually when we start to develop open courses, we have many challenges, and that are listed the challenges in open education. First of all, as the technologies are changing very fast, we have a lack of academic staff competences. So if you will follow the DCOMP areas of competences for teachers and trainers, you will see that there are a lot of related with digital competences. So a lack of academic staff competences is the main challenge in education design. Choosing digital technologies, content, and process that can be seen in all educational sectors, affecting all aspects of the educational value. So curricula reform, teaching and learning practices, assessment, continuing and professional development, which is directly related with academic staff competences. So we are focusing on 4 dimensions model before starting to design online courses. So pedagogical skills, what was mentioned as one of the main areas, technological skills, structural skills, and planning skills, how we are planning open courses to be successfully implemented and qualitative. So the solution we are looking for, we found that integration of competency framework into the educational platform ensures the direct link with the competences, learning units, and learning outcomes, what you can see in the picture as well. So you can see that some skills what we are usually looking for to get, so are directly linked with learning units and, of course, learning outcomes as well. It is very important also to assure the interoperability strategy. And this is also important when we are looking to the whole context of the online course. And of course, our approach needs to address these key challenges related to the coordination of different components of the educational platform, and identified in our case relations between all components of the educational platform helps assure the quality not only for the design process, but also of the delivery process as well, because assessment is usually the main part of the completion of the module. So, however, we are analyzing the conception of assessment in open online courses. We also made evaluation of the teachers' competences in the same way as we planned. So we focused also on pedagogical skills of teachers required for open online courses design. We also focused on technological skills, but are also going together in the same role as pedagogical skills and structural skills and planning skills, what is showing the whole conception of the open online courses and all the processes of planning, design, delivery, implementation, and evaluation. So as we practically implemented that findings of the research, we developed the model, competences model in the Moodle environment, how that competences framework correlates with the assessment tool. So course participants were able to self-assessment their level of skills, and the levels we identified as according to the Bloom taxonomy, that one is from the remembering to creating levels, and you see in the picture below the example of our online course. For conclusions, I could say that it is very important to encourage the staff, academic staff, for new competences to design and to deliver courses, because technologies are changing very fast. And new pedagogical approaches are also important in this case. To enable academic staff to develop the integration technologies for effective use of digital technologies in education, and to assure the engineering solution of educational platform by extending and relating with the competences framework. So in this case, we can ensure a very successful and effective assessment in our online courses. So that is my short presentation, and thank you for attention.
Thank you, Daina. Maybe some questions? And what about, no, not in general. Okay, you can continue with the second presentation.
Okay, thank you. So my next presentation is on the game design framework, which one was also discussed in the in-game project financed by the European Commission and coordinated by Salamanca University. Kaunas University of Technology is one of the partners of the project, and we are very happy we can take part in this project by our skills and competences on different contributions for games design framework. I will present some introduction, findings, and conclusions and recommendations for the game framework. Introduction and challenges are listed below and are focused on the literature review to gain deeper skills by playing games. That game thinking and motivational design have a positive influence on motivation. Gamification of the educational processes has multiple uses, but it can also be used with teaching methodologies, such like problem-based learning and challenge-based learning. Technological advantages helps to improve student skills. However, pedagogical aspects are important in planning and achieving learning outcomes. We are analyzing pedagogical aspects framework for the game planning. So you see that we are focusing mostly on civic skills in our game. So the technological aspect is not only the one what I mentioned, also it is very important pedagogical implementation, which is focused also on some learning outcomes, and we should find a solution, a good solution for the game implementation. So if you look to the game mechanic, there are several necessary specifications and guidelines for example, for audiovisual content could be distributed in the game, for example, audio-related guidelines, video-related guidelines, and general technical guidelines by choosing game engines and development environments as well. So these mentioned factors also increase our quality of the game, and we could focus on the successful game implementation. So you see also in the picture the game mechanics. When we start, we get some introduction in the game. We also follow the tutorials. Also doing some activities, implementing or participating in some activities or tasks. Then, of course, game can have some simulation part. We also some actions could be implemented by participants, and that also a very important part is reflection and feedback. As well as assessment, what is also related directly with the learning outcomes. So as a technological framework for game design, it is special for civic engagement and social inclusion, and we focus on the steps for game implementation. You can see in the picture of the slide. So that are very important factors, and technological framework also includes a full learner journey from the beginning to the end of the game. What is also very much important, it is important some audiovisual solutions for educational game, which makes him more engaging and more interactive. So type of backgrounds, music is also having a big role in the game. As well as three main functions of video game music: environmental, immersive, digest. It's very important how the music supports a game narrative. So in this case, it is very important when we need to get some engagement, to invite more participants and more users to learn and to get new skills and competences. So a video related choosing between 2 and 3-dimensional graphics is also in the conception. So 2-dimensional games like flat graphics, the sprites do not have 3-dimensional geometry, and 3-dimensional games. So that is the possibilities for the game conception. Requirements for game planning that are also mentioned in the picture of the slide. That what is very important when we start to develop a game. There are team competences, the game development pipelines, the animation, of course, what is also should go through the game. The volume of data, technical limitations, the game performance, the game levels, the game usability, and of course, chosen devices and platforms. For general requirements, it is important to choose an engine that is able to create narrative applications for different platforms, and to choose an execution platform that runs on different operating systems and devices. Of course, our learners are very much expecting that the game will work also on mobile technologies, not only online. And for conclusions and recommendations, what we analyzed and we got from our research, we can identify that the team competences to develop the game is on the top, and that is very important. The game engines that support 3D games are more sophisticated. The game development pipelines as well, 3-dimensional games usually have more complex pipelines, and game engines required to use the use of specific. The animation, when creating a 3-dimensional animation, we need to deal with separate animation assets, bones, skins, and so on. And the volume of data is also as a criteria. If the amount of data might be a problem, one needs to keep in mind that 3-dimensional games usually contain a lot more resources. Possibly technical limitations to keep in mind, various restrictions imposed by target devices, platforms, and game engines used. And the game performance, if the game is dedicated to virtual reality devices, strict performance requirements are imposed by published platforms. So that is also the next presentation. Thank you for attention.
Thank you. Please don't close your slides. We saved a lot of time. Maybe do you have some questions? No? Maybe I have some questions. You presented that you've done some research. What kind of method did you use for the research? In slide 11 maybe, but it doesn't matter.
Of the in-game?
Yeah.
So yes, we analyzed the existing practices, and we analyzed how the game could be constructed, because it is just a framework for in-game, and we also our team also worked on the technological possibilities to be selected for the game.
Thank you. More questions? What does it mean to have session on Friday, 5 p.m.? Thank you, Dina.
Thank you.
Fantastic presentation. Sorry, please don't move. Okay. Because of COVID virus, like this, you can use this distance. Thank you. Thank you. Okay, I will stop sharing. And now I would like to present our next speaker, Diana. Sorry, Diana, but I would like to tell our old friend from Romania. And Diana, floor is yours. You have maybe not 15 minutes, but much more. If you want, you can present in more detailed format what you've done in your research. Please.
Thank you very much, Dana, and thank you everybody for coming here to the ICIST. It's not me who is going to do the presentation, but my colleague Silvio Vert, who was also working into the DigiCulture project, in which also Danga was part. So Silvio, please.
Hello to all. Thank you, Diana. I'm going to share my screen now. Let's see if it works. Sorry, just a minute. Okay. Yep, everything okay? So I'm going to present now our study, Initial Usability Evaluation of the DigiCulture courses on UniCampus. I'm Silvio Vert. I'm going to present the paper, and together with me is also Diana Andone from the co-authors from the Politehnica University of Timișoara. So the DigiCulture project that I'm going to speak today about, it's an European Erasmus Plus project between multiple stakeholders in the European Union, Romania, Italy, Denmark, Austria, Ireland, Romania again, UK, and Lithuania. And the project aims towards multiple things. First is to raise the awareness of training in digital skills for the creative industries, to design, validate guidelines for digital competencies for creative industries, to create a virtual learning hub, online and mobile, and I'll show you more about this in a few minutes, to design, develop, and deliver digital skills on social inclusion for creative industries course, also validate digital skills assessment and open badges, enhance collaboration between multiple stakeholders in creative industries, and validate the use of digital skills badges towards this aim. So the DigiCulture course public interface is our website, digiculture.eu, and where you can find the information about all the courses, all the mini MOOCs that we have developed for this, the training in digital, in creative industries sector. The courses themselves are on our online platform, UniCampus, that we've talked about many times before on unicampus.ro. And the DigiCulture mobile app you can find on the Google Play and on the App Store. And you can see here a lot more screenshots from the application, and we invite you to download the application and learn about the courses. So actually, during the project, we developed 13 mini MOOCs courses, online blended learning. It's important to say that these are free courses, ranging from the history and applications of the Internet, World Wide Web, to augmented and virtual reality, digital management in culture, online mobile digital media tools, also digital safety, security and ethics, and mobile apps, and all kinds of important materials and information for those working in the creative industries and wish to enhance their digital skills. What we have done exactly in this in our study is based on the scientific literature that we've studied. Of course, we mentioned other usability evaluations that were done in MOOCs by other researchers, but also is based on things that we've done before. So usability evaluations of the web-based virtual mobility learning hubs and also mobile applications, mainly for the other projects that we were involved in, such as Open Virtual Mobility Project. So our methodology for the usability evaluation of the digital culture courses were based on two research questions. First of all, how is the integration of the DigiCulture courses on the Unicampus platform? And second of all, what is the students' experience of the first implementation of the DigiCulture MOOCs? So it's very important to say that this is an initial usability evaluations. Some of the courses were very fresh, were put on the platform, were not really finalized and everything. But as the methodology of the usability says, we have to do multiple times this process in order to do a continuous improvement of the courses and of the platform. So the testing method that we've used are focus group, user observation sessions, error testing sessions, and survey, or if you want, questionnaire method. And I put there on the slide each testing method to what research question does it help to answer. Second of all, also about our methodology, participants were 26 first-year students that we are teaching in the multimedia technologies master at our university. They are students aged between 23 and 26, good IT skills. We tested both the web platform of the DigiCulture courses and also the mobile applications. We tested 8 of the 13 mini MOOCs, the 8 that were available at that time. When did we test them? We tested them during 2 months, May and June 2020. And it's important to say it was remote usability evaluations because we were already during the COVID-19 pandemic. The implementation was according to the literature and the guidelines for doing a usability evaluation. So user observation sessions where we looked at the users and what exactly they did in the courses. And we used everything that was recommended, like video recording of the sessions, confidentiality agreement, pre and post questionnaire for the students. We gave them tasks and everything. And we had a focus group after the user observation sessions where we discussed with the students, also gave them some tasks to think about, and we had a discussion. Students were also required, this was another time afterwards, to enroll in the courses and watch each lecture and lesson and write in a collaborative document what errors they encountered. And they also had a questionnaire to fill in about their experience during the enrollment and the studying of the courses. So towards the conclusions, we derived a lot of usability, a lot of insights, usability problems, and made recommendations. I don't have enough space on the slides to put all of this, but I've put some examples here. So let's say, catastrophic usability problems on the scale of Jacob Nielsen. So they had a very hard time to find the enroll in this course button, which it's obvious that it can stop users to enroll in the course and do everything what follows next. Some of the quizzes and videos were not displayed properly, and it was very important to test with a lot of users and on a lot of devices and mobile and web to find out about all this stuff. And they also had a problem marking their activity as completed. For example, this was a major usability problems because they didn't know if they finished the course, and they couldn't get their badge because of this. But despite the usability problems that the students reported in the initial implementation of these courses, they appreciated the platform, and they said that they will use the website and the application again to study other courses than the ones that they were enrolled in for the usability testing. Our conclusions are mainly answers to the research questions that we established at the beginning of the presentation. Of course, how is the integration of the digital culture courses in the campus platform not finalized as we kind of expected, and some of the links and content modules, navigation items were not properly working, which could have led to unsatisfied users. And the answer to the second question was the initial experience of the students that enrolled in these courses. They suggested several improvements, and it's important that we found usability problems both on the let's say, general interface of the MOOC platform, but also the content of the courses. But it's very important to mention that they graded the courses with the adjective good on the system usability scale, adjective rating scale. And they said that they will use the platform again. In the end, as a summary, we applied a mix of 4 usability evaluation methods with 26 participants during 2 months, and we derived usability issues pertaining to a MOOC platform, and we made recommendations for solving such usability problems. We showed how this kind of study can be made in a remote setting, because everyone was working only online at that time. The study had a practical outcome for improving the DigiCulture courses, but it also shows how it can be done in a pedagogical way to also teach students how to do usability evaluations. Thank you very much. This is the international, or part of the international team that is working on the DigiCulture project that ends this year. And if you have any questions, we are open to them.
Thank you, Silvio. But maybe before questions, maybe I would like to ask Diana. Diana, maybe could you do you want to add something? Because Diana was our leader and coordinator in this project.
The only thing which I can add, and thank you very much, Danga, for this, is that I will currently encourage everybody to join the courses, or the DigiCulture courses. There are 13 different courses in 6 languages. It also exists in Lithuanian, so Lithuanian colleagues can join it easily and access it easily. So please join the DigiCulture courses and take them for free. They will give you a lot of knowledge about digital competencies and also badges at the end about this. So please do that as soon as possible. And thank you very much for the opportunity and for the evaluation of the ICIST project. And we are sorry that we cannot be with you now.
Okay, thank you, Diana. And maybe now it's time for the questions. No. Okay, and now we are waiting for the next presentation from Romania. Maybe Vlad, I am not sure. Vlad, floor is yours.
Yes, thank you. Thank you so much. I'm going to present. Let me share the screen. Okay. So our paper is self-assessing teachers' competencies for curricula modernization through MOOCs. And this paper was written jointly by several people involved in the Erasmus Plus project Mode IT. The consortium is formed of Fachhochschule des Mittelstands from Bremen in Germany. They coordinate, and also in the project is KTU, the host of this conference, Anadolu University from Turkey, Polytechnic Institute of Porto, and of course, us, the Polytechnica University of Timișoara. So what is the purpose of this Erasmus Plus project? The name is Curricular Modernization by Implementing MOOCs Model. The goal is to foster integration of open online pedagogies into formal courses and programs with the purpose to make these more flexible and attractive for students. We have three declared objectives of the project. We want to boost awareness for higher education educators in MOOC design and delivery skills. We want to develop innovative MOOC-based instructional approaches for the curriculum design. And also we want to raise awareness of the learners about how they can improve their learning experiences through participating in MOOCs. The project has several intellectual outputs, and this research is related to the first of them. So we first developed an online self-assessment tool so that teachers all over higher education can self-assess their skills on several topics that the project was reaching. Then we had the designers training program for people who are going to support higher education teachers in designing their curricula and their courses. We developed and ran an online training for MOOC design and implementation with higher education professors from all the partners in the consortium. And finally, the step which is in progress now is to redesign some of the courses in MOOC-based curricula and MOOCs. The present paper aims to prove that the results obtained from the pilot implementation of the self-assessment tool for educators. So we want to show our results about this evaluation. It is an overview of the pedagogical and technical design of the tool. This is provided here, and the paper portrays the innovative features of this self-assessment tool, outlines the evaluation methodology for piloting of the tool, and we present the analysis of relevant evaluation insights followed by some final conclusions. So how we developed this self-assessment tool? As I was saying, this was the first output, intellectual output of the Mode IT Erasmus Plus project. We had an open online teachers training program. So for this, we needed to try to do some assessment of the skills and abilities of teachers participating in that program. We, the experts in our project, identified 27 most relevant competencies for creation and delivery of MOOCs, and we organized them into 5 areas: pedagogical competencies for designing student-centered learning, MOOC-specific competencies, technology-related competencies, competencies related to theoretical foundations of MOOCs, and finally, competencies about MOOC integration into formal learning. The self-assessment tool is designed to allow the teaching staff in higher education institutions to assess their competence level in designing and developing MOOCs, and also they are getting immediate feedback for their possible improvements. Following a competence-based approach, the training program we design is composed of five learning modules, and this was also implemented into the self-assessment tool. Foundation of online learning is the first module, followed by MOOC course design, MOOC content production, MOOC delivery, and MOOC informal learning. We designed a conceptual model, and actually this was mainly from the work of our colleagues from KTU. So a conceptual model used for the development of the self-assessment tool. You can see in this figure how the model is looking. Each module and topic covers at least one competence area and aims for at least one learning outcome, and the outcome or competence of a particular level. The purpose of this tool was to assess the level of competence that each respondent had in each area, and also to give, as I said, an immediate feedback and a recommendation for how they can further develop their abilities. The self-assessment tool is built in a modular way and has 5 parts corresponding to the 5 identified competence areas. We also decided to use Bloom's taxonomy to formulate the statements of answer inside the tool. Each set of possible answers consists of 7 statements. 6 statements correspond to 6 levels of the cognitive domain from Bloom's taxonomy. Statements of the same level in each question are formulated applying the same patterns and receive the same grade, as you can see from this table. If the respondent does not have any experience with a particular competence, there is a possibility for them to choose the option "No statement applies," which is graded in the tool with the score of 0. After taking the assessment, each part of the tool returns for a final grade, which is an average of grades assigned to the level of competence indicated by the respondent. The overall feedback of the assessment depends on the final grade obtained. Following this same principle, we specified 6 ranges for the overall grade and specified corresponding feedback. The meaning of each range feedback is close to the meaning of the level of the cognitive domain defined in Bloom's taxonomy. This evaluation study proposed to explore the self-assessment tool participants' perceptions and perspectives regarding effectiveness, efficiency, appeal, and sustainability of this self-assessment tool. More precisely, we wanted to identify what participants were thinking about the user-friendliness of the tool, the sufficiency of the user guide about how to use the tool, the satisfaction with the tool, the effectiveness and usefulness of this tool, the advocacy and competencies covered, the appropriateness of the definitions of the competencies we provided, how adequate the use of Bloom's revised taxonomy as competence level was, and finally, the satisfaction with the feedback area received at the end of each competence. We collected data through March, April this year, and we had 64 voluntary participants from the 5 countries of the project. As I mentioned, Germany, Lithuania, Portugal, Romania, and Turkey. 2/3 of these participants were female and 1/3 were male. We also had some participants who preferred not to say. Also, you can see that we had 9% people under 30, 34% people between 30 and 39 years. Also the same percentage for people between 40 and 49, and also around 20% people above 50 years old. How we collected the data? Through an online education form, and we decided to divide this form in 4 sections. The first section was supposed to identify the user-friendliness of the tool, so questions about access and use, and to see the sufficiency of the user guide, the participants' overall satisfaction with the tool, and the effectiveness of the tool in helping participants identifying their strengths and weaknesses about each competence. The second part of the questionnaire of the form was supposed to show the effectiveness and usefulness of the tool, and to evaluate, sorry, not to show, and to see the advocacy of the competencies covered, the appropriateness of definitions of competencies provided, and the use of Bloom's revised taxonomy. The third section was a short version of the user experience questionnaire, where pairs of contrasting attributes may apply to the self-assessment tool, and participants were evaluating each of these pairs. Finally, the last section of the form was supposed to show thoughts, comments, and recommendations about the strength of the tool and the areas which needed improvement. I'm going to present some of the results, which we also presented more detailed in the paper. So in the first category of questions, one of the questions was related to access and use, and we used in many parts of this online form 5-level Likert scale with options from strongly disagree to strongly agree, as you can see in this figure. So we see here the participants' agreement level related to statements about the access and the use of the tool. And we saw here that the highest level of agreement was received by the development of the user guide of the self-assessment tool, which showed us the way in which the partnership designed very explanatory and useful this user guide. The less agreed statement here was that participants can use this tool in their course. And these should further encourage the partnership into finding the reasons for these in some future research. Another question we asked was about the participants' agreement level related to statements about the aspects of the tool. And the scores received were mainly positive. What can be improved? The statement that the tool covers appropriate range of competencies about MOOCs could be further improved, and some participants said that this should be more detailed in terms of technical competencies and content design and creation. Also, what we should improve more was about the descriptions of the competencies, as some participants felt that these were not precise and could be simplified because they were maybe too complex. The best results here were about the competency levels accurately representing the user's levels. So the participants loved that we used the Bloom's taxonomy, and they felt that the competency levels were very nice and suggestive. I mentioned also about these contrasting items part of the form. So we define some attributes, which you can see here, and we ask participants to rate which of these they feel more close to in relation to the self-assessment tool. And we can see here that they felt that the tool is supportive and quite easy to use and efficient, but what we saw was that maybe the tool is a little bit boring and too conventional, and it's not leading edge. The results were encouraging, but of course there is still a need of improvement. The last section of our questionnaire, of our online form, was related to the overall evaluations and some demographics. So about the overall evaluations, we managed to group these in some categories. So we found that strengths of the tool are the clear formulations of statements, which almost a quarter of participants stated. Also, the fact that people are doing the self-assessment is considered as a big strength. The fact that they can receive an immediate feedback, and also the fact that the tool is easy to use, and that the concept and the relevance of this tool is very good for these pandemic times. What we need to improve in the point of view of our participants in this study is that we can make the tool more easy to understand, as it can be difficult sometimes, especially for teachers who do not possess knowledge about MOOCs and the terminology related to MOOCs. Also, the fact that we repeat ourselves in some formulations and we choose some long phrasing can be boring and annoying for some of the participants. What is interesting is that even if Some participants said as a strength the fact that the tool is easy to use. We saw also that some participants said that the tool is difficult to use. Also, people would prefer better design, and there were some problems with the language barriers. Let's see what are the conclusions of our study and what about our future research. So we concluded that the higher education teachers need to master new skills, becoming MOOC designers and deliverers, especially in these times. And we saw that the self-assessment tool allows teachers to identify the gaps in their competencies and skills. We saw general results which were positive and encouraged us to further develop the tool. And we found that the tool provides a precise profile of the teacher's abilities for designing and delivering MOOCs. However, of course, we found many areas where we need to make improvements, especially in concise definitions of competencies and also about the statements identifying the ability level of the teachers. But these will be presented in our future research. So this was, thank you, this was my presentation. And if there are any questions, I am happy to answer them.
Thank you, Vlad. Some questions? Yeah, please. Could you come here? They want to see you. It would be much more easy.
Hello, thank you for very interesting presentation. And I wonder, what is the main source? What is the main source of the questionnaires? Of a questionnaire, and do you use the same template for all the countries for self-assessment tool questionnaire and for courses, or exist kind of country-specific requirements?
Thank you for this question. So at first we developed the self-assessment tool only in English, but then the project is going to translate this in all other languages of the project. So also in Lithuanian is going to be, and it will be offered country specific. Also because the research showed that some teachers found some language barriers in the tool. So that's why the consortium wants to offer language specific tools. And
yes, but I mean not only the criteria of the language, but kind of, for example, one template for one country, not language related only. For example, kind of country specific maybe requirements can differ, or template can be different according kind of legal regulations or kind of policy of higher education or secondary education. I don't know. I mean this point of view.
Okay, yes, now I understand better the question. Thank you. Actually, we tried to do a unified template, since the consortium and the purpose of the project is to help states in all over the European Union. So we tried to make a unique template which applies in all countries. You are right, there are regulations in different countries, but we felt that the questions which we chose for the self-assessment tool do not come in contradiction with the regulation and the state of facts in each of the countries.
Okay, thank you.
Thank you. And maybe I have one question. In the beginning of your presentation, you mentioned that you identified MOOCs specific competences. What does it mean? Could you explain a little bit?
Yes, so you mean when I said that we had 27 most relevant competencies?
Yeah, and on the second maybe slide, not on this, but on the second, it was MOOC specific competencies.
Yes, let me
sorry, but we have time.
Yes.
Yeah, fantastic. Yeah. You know your slides. Yeah.
We tried to, together with all the partners, to find what were relevant competencies for MOOCs, and we identified many of them related to the design of the curricula, related to synchronous and asynchronous activities, about types of assessment, about integrating different types of content, text, video, audio, images. then we tried to group these and find the most relevant according to the experts we had in this project. So it is subjective. That's why we also do the evaluation to see the opinion of participants. And if you remember, I mentioned that some participants wanted more technical competencies in our questionnaire. And what we did was, so we decided what are the most relevant competencies, and then we grouped these in these 5 main areas, which you can see here.
Okay.
So to answer, it's subjective, but based on our results, we think that we covered the most relevant ones. Thank you.
Okay, Vlad. You have to be happy. So many questions, too.
I am honored.
Thank you. Could you close your sharing?
Actually, I think we also have a question.
You've done it, yes. Yeah, and as you know, we are doing record of this presentation, and of course, you can make some screenshots for some report, for example. Yeah. Oh, sorry. Do we have some? No, it's not question.
Yeah, we have.
Oh, yeah. Please, Pavel, floor is yours.
Okay, thanks. This is just a short comment because I have taken part in projects which is for several countries in the European Union. And there was a requirement when we make some blanks or forms to be the same, because in this way it's possible to compare different countries. If they have different blanks, it is very difficult to compare them. So maybe this is also a requirement and a kind of answer of the first question.
Okay, thank you, Pavel. Thank you. And now, Pavel, you can leave on the screen. Thank you, Vlad. And I would like to thank to all Romanian team. Really, you are supporting our conference, as I remember, maybe during last 6-7 years, as I remember. Thank you very much. And greetings to Radu. And now I would like to invite our speaker from Bulgaria. Please, Pavel, could you can do your presentation. I think you will share your slides.
Yes.
Yes. Floor is yours.
Mm-hmm.
Okay.
It is okay now?
Yes, everything is okay.
Just for a second, I will turn off my video because I will show animations and just to save web traffic. So just the video will be turned off. I will share it again. So it should start again.
Okay, we can see your slides.
Okay, thank you. So my name is Pavel Bochev, and I will present our paper together with Sveta Bocho. It is called Visual Educational Simulator of Pandemic. And it is a work in progress, which means we are still working on this. It is not finished. And our goal is to make a design and implement a pandemic simulator. The purpose, the primary purpose is to make visual simulations of different pandemic scenarios. However, we also want to use this simulator for very different educational opportunities for students. And you can see here a snapshot of the simulator. If I have time at the end, I will show some animations. So our workflow follows very strange methodology. We start with the overall design of the simulator, followed by implementations of several features. We are here at the end of the implementation of these features. For each feature, we have provisioned some medical or health activities. These are written on the top, and some educational activities. They are still in design phases. So when the implementation is ready, we will split the process into 2 different paths. One path, you make simulation scenarios and you run them to get some experiments in the result. And the other one, we will create educational content and use this for teaching activities. So the core decisions of our work was to make a virtual city with virtual people who live there, to make the behavior of the simulator emerging, so we do not impose any specific rules, they just happen by the way. But you want everything to be configurable and to be unpredictable, so we are not aware of the final result. However, we also had a secret goal, which is not shared in the paper, so you're the first people to hear it. it is we want to try flipping interdisciplinary education. Here is one example. On the left, you can see traditional application of such idea. We have a model from one discipline here, and it is projected in the context of another discipline. For example, it could be matrices from geometry are applied to computer graphics as a way to rotate or translate or scale images. On the right is what we try to do. We want to make one model which can be projected into different disciplines. So the model is the major unit and disciplines are just small projections. And in this way, we want to cover areas like mathematics, physics, and computer science, biology, geography, and even go to urban design, to art, psychology, and human behavior, healthcare. And this is within the same model. So the rest of my presentation will focus just on showing some features of the simulator and describing their potential educational use. I have picked two topics. One is the two-dimensional and three-dimensional design, and some interesting ideas about the virtual people. Because this is a work in progress, at the end I will show some preliminary results which were not shared in the paper because they are new results. So I will start with the two-dimensional design. It is a map of the city and it uses recursive algorithms. There are several such algorithms where we had to adapt the algorithms to make them more plausible to look like a street layout. So in this case, it can be used for teaching recursion to students or even iteration and how to modify algorithms to make them suit our particular needs. On a larger scale, we wanted to make everything configurable. So we have about 130 parameters that control almost every aspect of the simulator. And this is example how we can develop upscalable source code writing in students. The image below, this series of images show urban gradients from metropolis to the left to small villages. All these are the same simulator, but with different initial parameters. If you go to three-dimensional design, we use special techniques to control randomness because we want the city to be random, but we do not want to be completely random. So, for example, if you want to define business districts right here on the top right, white areas and with high-rise and low-rise buildings, we can use Perlin noise. It's a special technique, but the Perlin noise on the left is not immediately applicable, so we have to modify it to make it like more spiky areas. This is in respect to the static content, and the last portion of the static content are the three-dimensional objects. It is like buildings or houses and trees. And it was a very nice introductory blend between computer graphics and other areas. The idea here is that we need to apply specific optimization techniques because we need tens of thousands of objects which are rendered in real time. We also use shader injection and we use programming directly in the graphical processor. The second idea about this graphical processor is that we wanted to have a photorealistic graphics which can be turned on or off depending on the situation. So here are two examples of using soft and hard shadows with textures which are generated at runtime. These are called procedural textures. And we even wanted to model like natural phenomena, example sunrise and sunset, because this not only provides the feel when you look at the simulation, you feel like you're really inside the simulation, but it also compatible with the behavior of the people. And here you can see the city at sunrise. Because I started to talk about the behavior of people, we have a special invisible navigational mesh. This is a map that shows the places where people can go. It's a very complex graph. And the interesting thing is that students, they learn about graphs, but what they learn, they cannot apply it immediately here. One example of this is this situation when we intentionally forget about the classical algorithms for optimal routing or short distance, because you want the people to behave humanly. For example, this is a heat map of going from one location to another location. If you use optimal algorithm, it will pick every time the same route. We use suboptimal algorithms. We change the algorithm so it is not always optimal. We introduce some randomness, but you control it. So the path is every time it is different. It is somewhat random, but it is not completely random. It is like the person has some target, but it is not lost all the time. Another piece of data which is used in the simulator are different graphics. For example, here is the population. The left is what is actually used in our model. On the right is the actual population for the last year. On the right half of the screen, you can see the viral shedding curve of COVID. This is this curve. The left is how we make it, and the right is how it is actually measured by scientists. And the idea here is that for all these types of data, we use different mathematical models. For example, the left one uses random numbers which are added to generate a curve which is like this. On the right side, we use spline curves. So we develop and express different ideas from numerical and procedural approximation. And this is a very nice idea for students. They can explore different parts of mathematics in physics and biology. As for people, because they're the most essential part in our simulation, their shape is sculptured from a single template. So all these people are actually the same people, but in the graphical processor, their shape is modeled like tall people, short people, or slim or not so slim. And not only their shape, but their motion is also modeled inside the shader. So this is done in real time, not predefined externally. And some preliminary findings are very interesting because we are still developing features. So officially, we have not started to make results. But anyway, for example, the left snapshot here shows some emerging phenomena when there are a lot of people doing their everyday business. And when they walk, they form like human streams around buildings. On the right side, you can see congestions of people near pedestrian crossings. All these are not only visual effects, but they're used later for the medical simulation, because when there are a lot of people in one place, it is easier to infect each other. Another interesting power which we found in our simulator, which was not planned initially, was the massive possibility of making bugs. Almost every aspect of the simulator while we make it is a fruitful source of bugs. These two snapshots show examples of wrong scaling here on the roofs. And the right one is very interesting. This is a bug when the sun is below the horizon, but the ground is treated as transparent. So the sun on the other side of the ground makes shadows of the trees on the buildings. And every part of the simulator is a very interesting area of bugs, and bugs are very educational, more educational than other parts of our simulator. And of course, we wanted to simulate not only medical situations like healthcare or COVID-19, we wanted to make other viral events like strikes or rumors. These three snapshots show one situation when we asked all virtual people to go to a park, but we didn't give any other instruction. So they gather here in the park, and they start working without any purpose. They just go to the park, gather at one big group of several thousands of people. And because this is a work in progress, I will try to show some new things which are not written in the paper. These are snapshots. The first one shows electric lights during the dark hours and during the night. They're also activated randomly but controllably, so it depends on the outside time of the day, depends on the side, on the sun, depends on the amount of people, and everything is done in real time in the processor. And the other snapshot shows a group of people. Every one of them is following his or her own personal daily schedule, but as a combined group, they exhibit some patterns. Another new things are the virtual people. We have made a lot of efforts to make them in real time. So now we can have thousands of people, they are working at the same time. This is done in real time without some special hardware. On the second snapshot, you can see that you can dress them. This dressing in this variation in appearance, everything is done in real time in the processor. And the third snapshot shows some mode when everything is muted as a color except for the health status. So you can see here the red people are those who are very deep into the illness. There are some small indicators. There is like indicators of their health status. So we have made a lot of things which are configurable, and maybe this is time to thank the two programs. One is the National Scientific Program, Information and Communication Technologies in Science Education and Security. And the other one is the Sofia University Research Science Fund project. It is called Integration of Competence-Based Learning in Higher Education. I'm not sure about the time. I think maybe we have a little bit more time. Is it okay to show some videos? Maybe I can show. We have 5 minutes. The first one is the sunset and the sunrise in the city. I'm not sure how well the video will go through because we have several hundreds of videos, different areas of the simulation. I will show only 4 of them. The second one, I will run them in parallel. It is the group of people, how they form like streaming. At the same time, I will start the third video. It is for different variations of people. And when I said that everything is configurable, we have made a dedicated configurator. Here you can see just scrolling all the parameters that can change the behavior of the simulator and the behavior of the elements inside. You can control anything from the size of the people to the how wide are the streets, how many trees you have, whether you want shadows or you want without shadows, because this changes the performance. The infection, how strong is the infection, or the initial health status of the whole population. So I think this is maybe enough for now. The scrolling of the parameters are still going on. So I want to thank you for your attention. And I will start again my camera. If you have any questions, I can answer them now, or you can send them by email.
Okay, thank you, Pavel. Really, during last few seconds, really, it was very interesting because first time I saw 4 videos in one time, on screen. It's really something new for us. And really, subject is interesting. And some questions? No. And as I see from, yeah, could you send by chat from the, because as you know, as I mentioned, we are broadcasting on the YouTube too, and now we are waiting for questions. Yes, question to Pavel. You can read yourself.
Where to read the question?
You can see, okay, I can read.
Question I see only one yes in the chat.
On the chat, if you wish. Did you include or are going to include virtual vaccine in your simulation model?
Virtual what?
Vaccine.
Vaccine.
I think of COVID vaccine, I think.
No, currently it is not included. Currently there is only a personal immune system of the person. You can control how quickly a person recovers. We have not added vaccines in this model, but it is not difficult. I mean, it's not a technical problem. But it is a nice feature to have a vaccine, or maybe to have a vaccine not to all people, but different vaccines to different group of people to see whether there is any differences. So thank you for this idea for the virtual.
Yeah, thank you.
There are no, but we're still working on this.
I think it's very important question, especially now. And now, not more questions really. I will. Okay. I will show gallery. And now it's the last minutes of our session. Maybe some of our remote speakers, presenters, if maybe do you want something to tell us? Now we have 4 minutes. No. I would like to thank to all of you, especially our presenters, our remote participants, our participants sitting in this room, but especially I would like to thank all IT team. Can we thank to all of them? Thank you. And as I mentioned earlier, you can see records on the portal. And again, thank you very much. And I would like to wish you all the best. Please be healthy and more creative in the future. Because very short, these sentences could be in the beginning. Usually when we speak about today's not so nice environment, I'm speaking about virus and COVID, but when you speak about distance education, I think now we have gold age. Because we made during 2 years much more like 20 years before. I would like to wish you all the best and see you in the next conferences. Bye-bye.
So thank you very much for chair. Thank you. This is certificate of participation.
Thank you.
It's also souvenir from organizers.
Thank you. Okay, now is final word. Thank you again and see you on the next year. Bye-bye.
So, okay, so can we start, yeah? Okay. So, okay, so now we have the final part of our conference, and the conference organizers had a responsible and hard work to choose the best conference paper and presentation, as there were many contenders for the title of best article of conference from different sessions. However, the award is only one, and the best paper awards goes to Romania. Yeah, and congratulations to our colleagues for article and analysis of ED line algorithm in urban street view dataset, and congratulations for authors, so Kiprian Torhei, Guras Makofan, Silviu Vert, and Radu Vasiu. Congratulations, and the signed digital certificate will be sent for you by email. And thank you very much. And I would like to thank all those who contributed to the organization of this event, and especially authors, reviewers, keynote speakers, chairs of the special sessions, faculty and university administration, including the dean who participates on site, and organizing committee members, especially once more for technical staff and all others who contributed to the conference, but I did not mention. And I would like to invite all of you to the next year's conference, ICIST 2021, which I hope will be organized in traditional way only. And I hope that we will receive a large number of new scientific articles in which we will present further results of your research, and we will be able to meet each other over here live in Santa Valley next year. So thank you very much again. Good luck, and hope to see you next year in Kaunas live. Thank you, and have a nice weekend. Thank you. Bye.